and today we'll have two sessions, and in the afternoon we'll have valedictory program. So the first session will be taken by Dr. Anu Singla, who's head the Department of Electrical Engineering in Chitkara. She has a total experience of 20 years, out of which 4 years are in industry and 16 years she has been in academics. She is a very good teacher, a very good researcher, a very good programmer, and she has been with Chitkara for last 16 years. So you can imagine for an industry, for a private industry, if you are working for 16 years, that shows your caliber, that shows your position in the institute. And without wasting any time, I would request Dr. Singla, Dr. Anu Singla, to start the proceedings. Our topic today is on energy efficient technologies being used in industries. So she'll be talking to you on efficient technology, energy efficient technology. As I said, the paradigm shift is from the intensive energy technology to the energy efficient technology. So what are the technologies being practiced in industry? That in brief, Dr. Anu Singla will discuss with you. So I request Dr. Singla to start the proceedings, please. Thank you.
A very good morning to all, and I thanks Dr. Chatterjee for giving me a platform to share my knowledge with you people. As far as energy efficient technologies are concerned, it's a very vast topic, and I have just taken an extract from these technologies to share with you people. Why we talk about the industry, if you see the energy statistics and all, we can see that 45% of the energy is consumed by the industry. So it means if we opt for the energy efficient measures in the industry.
Till 11, then there will be a tea break. 11:30, 11 till the.
Okay, sir. So we see that 45% of the energy is consumed by the industries. So that's why we are talking about the energy efficient technologies in the industry, because there is a major scope to save the energy. Now, if we see which are the main key areas of energy consumption in the industry, we have the electrical systems, lighting systems, then electrical motors, we have HVAC systems, compressed air, fans, blowers, boilers, refrigeration, and so on. So these are certain areas which consume energy in the form of electrical energy as well as in the form of a thermal energy. Now, before we go for the energy efficient technologies and say if you go for an industry, let's see that how the energy invoices are being done. So we take the data from last few years and we see that what is the energy consumption of the industry from the bills of electricity as well as the bills of the thermal energy. Then from those bills we can relate the data of consumption of the energy in the form of electricity or thermal energy, and then correlate this cost with the production. So we just make a link between the production of the industry as well as the. So based from the energy invoices and all, there are 2 points: electricity as well as the fuels in the form of a thermal energy. So all the fuels purchased by the industry, they are converted to the common unit kilocalories. Now based from the energy invoices, we just make a pie chart for it and we see what is the form of energy used in a maximum way. Like say for example, I have taken one data. Here the electricity consumed is 45%. So it means 45% of the total energy comes from the supply from the electricity, then furnace oil is 38%, then LPG is 12%, and so on. So now we convert all these units, like LPG will be measured in a different unit, electricity is measured in the unit of kilowatt hour. So all the fuels, all the energy sources, they are converted to the common units of kilocalories. So second table, that is a fuel conversion data. So on one side we have taken the energy sources, then we have taken the supply unit, and then we have converted those units to the kilocalories. So based on that, we again make a pie chart, because now the unit is same, then we can say that which component is consumed in a maximum manner. From that, we find out the energy consumed for the period, that is equal to C plus M into production for same period. C is the fixed cost. So whether there is any production of the industry or not, there is certain part of the energy which is consumed in the form of auxiliaries, say lighting systems and all. So that is the fixed cost which is occurring in the industry, whether production is on or production is off. Then M is the actually energy consumed corresponding to the production period. So from that we just find out that what is the energy consumed, and then we relate it with the production. So it's the analysis of energy consumption and the production of the industry, and we try to form a link between the two. And then when we have analyzed from energy voices that what was the energy bill of the industry, we try to understand that if it is electricity consumption, then in what ways energy electricity is charged from the industry by the utility. So there are different kinds of tariffs which change from state to state as well as industry to industry. So there are maximum demand charges, like this is the contract load of the industry, that at any point what can be the maximum power which can be drawn by the industry from the utility. So that is the maximum demand, and if the demand exceeds this amount, then there is a penalty on it by the industry. Then we have the energy charges. So it depends on the production. As long as energy is consumed, these charges will be applicable. Then nowadays is the concept of uh, day of the tariff, like at what time you are consuming the energy. So some of the utilities, they give the incentive if the energy is consumed by the industry in the off peak hours. So that way they get certain kind of incentive. Then high tension tariff, if the power taken from the utilities at high tension, then there is certain incentive given to the industry. So there are different kinds of tariffs which are applicable to the industry. So a person who is working on the utilities and all has to see that which charges are applicable, at by reducing which component. Overall, I can reduce the energy consumption as well as the electricity bill of the industry. And coming to the fuels, electricity was one part, and then there are certain processes for which different kinds of fuels are used. So we have a fuel oil, low sulfur, a heavy stock, then LPG, coal, ignite, wood, etc. So when we have to buy a fuel, so it means we want to reduce the fuel cost. So availability, cost and quality of the fuel, they are the main parameters which are to be taken into consideration while going for the purchase of these fuels. So one is price at source. So when we say that this fuel costs this amount, we must include the transport charges also, because it is not only the fuel cost but carrying the fuel from one place to another place, that is the transportation, then the type of transport involved, and sometimes happens that fuel is not available due to the transport problem, so that will result into the production loss of the industries. So those parameters, they need to be taken into consideration. Then quality of fuel is very important, then energy content of the fuel is very important. So it means when we have to buy the fuel, cost, quality, everything has to be taken into care, that is concerned regarding the purchasing of the fuel. Then fuel substitution is basically substituting fossil fuel with the more efficient and less cost fuel. Like for example of the fuel substitution is natural gas is becoming very popular. So the choice of fuel is moving towards the fuel gas, and like it is used in the feedstock in the fertilizer, petrochemicals, power and sponge iron industries. Then replacement of coal by the coconut shells. So that is one, that fossil fuel is replaced by the local available material. Then the replacement of light diesel oil by LSHS. So that is again replacing the expensive fuel by the cheaper fuel without compromising on the quality of the fuel. Then there are energy substitutions. Like for example, we need a heating arrangement. Now electric heaters, they are very expensive. So electricity cost is very high. So electric heater can be replaced by the steam heater. So that is one fuel substitution. Then we need a steam based hot water, then we can use the solar systems. So instead of using electric geysers, we can use the solar systems for getting the hot water. So these kind of certain things can be adopted in the industry for making the system as an energy efficient system. Now, when we talk about, we have understood what is meant by the different, what are the different components of the energy, then how the electricity is being charged by the utility, then what are the different kinds of fuels, and how we can go for the fuel substitution. So it means now the next option is to opt for the best operation and maintenance practices and adoption of best technology in the industry. So it means now fuel consumption, everything has to be taken care. So we have to reduce the consumption of the electricity or the fossil fuel or the substituted fuel by adopting the best practices in the industry. So certain examples are eliminating steam leakages by using the appropriate steam taps, then adopting combustion controls for maximizing combustion efficiency. Then there are certain equipments which can be replaced over a period of time because technology is changing very fast, and nowadays the new technologies are energy efficient technologies. So whenever any existing equipment has to be changed, it has to be replaced with the energy efficient equipment. And we see that electrical equipment works at its best at the rated specified conditions. So we have to ensure that the voltages and the frequencies at the electrical equipment terminals, they are at the rated values. So these are certain things, just a few examples, although we will be discussing all these things into the detail. They are to ensure that the technology is the best, maintenance is best, and we are opting for the best practices in the industry so that overall energy consumption has been reduced. So it means second is that we want to minimize the input requirement. So it means if we maximize the heat recovery from the waste energy streams, we can minimize the energy purchase. So it means if we are opting for the waste heat recovery systems, then total input energy can be reduced. So it means we have used some, say, cogeneration technologies, or we have opted for certain methods that byproducts they can be reused. So then we can opt for the renewable sources of energy like solar energy in the form of solar heating systems. And moreover, nowadays many of the companies are opting for the solar power plants so that they get a overall cheap rate of the electricity. Like a DG sets, the output is very expensive. The unit rate is very high when we operate the DG sets in the industry. So even installing a solar energy power plant, the payback period is small, and the industry can have the benefit of getting the electricity cost at the reduced prices, because the electricity cost or fuel cost, energy cost is the major component of an industry. So if we work out the total cost of the industry of the production, so fuel cost is the major cost. So these are the certain methods by which we can reduce the energy input. Now we start with what kind of energy efficient technologies can be opted in the industry. So this is just a simple power flow line diagram. We have a step down power transformer, then we have the distribution transformer, then we have air circuit because all the switchgear is there, then we have the distribution board, and from the distribution board the power is going to the different flows of the shop floors of the industry to different plants of the industry. Now if you see that during these there are ice-kira losses in the cables, then there is a heating of the cable joints which occurs, then there are certain losses which are occurring in the switch gear. So how these losses can be reduced? First thing, there are losses due to distribution transformers, then cable termination, switch gear, then poor voltage, poor power factor, voltage unbalance, and harmonics. So as we know that transformers, they have the maximum efficiency when core loss is equal to the ohmic losses. So it's best that the transformers, they should operate at 70 to 80% of the capacity so that overall loss of the transformer can be reduced. And wherever possible, the conventional transformers, they should be replaced by the energy efficient transformers which use the amorphous metal core. So it's there that 60 to 70% of the losses can be reduced, and 99.7% efficiency can be achieved for the 1000 kVA units. I have just shown one small comparison. Like see an example of 63 kVA transformer, and we have a conventional transformer, then we have the energy efficient transformer, that is EMT transformer, then there is a star labeling by Bureau of Energy Efficiency. So we can see that maximum total losses at 50% of the loading is for conventional is 490 watts, and for 3 star is 380 watt, and for 5 star is 280 watt. So total losses at 100% losses are less in the 5-star transformer. So we can say that what is the energy saving in that in the terms of losses, because when losses are less, it means we are saving the energy. Transformer is on all the time because it's always running, so energy loss is always taking place. So we can say that for the 3-star the energy saved is 165 watt, and for the 5-star energy saved is 315 watt from the losses only. Now let's come to the cable terminations. Everywhere when the connection has electrical connection has to be given to the equipment. So some cable joint will be there. So some cable, that is cable termination. Normally it happens that there is a poor workmanship and cable termination is not properly done, or there is some loose connection. So what will happen? It will result into the heat loss. So heat loss is nothing, it's just your power loss. So it means there should be a regular monitoring of all these cable joints as well as switchgear equipment and all. So we can measure the temperature on the regular basis, that we can use a non-contact temperature gun from which we can measure the temperature. So whenever the temperature is high, it means say there is any hot spot, the temperature is very high. So needful action needs to be done, some corrective action should be done, because although temperature rise is the indication of the power loss in the form of a heat. So that thing has to be corrected well in time. So normally sometimes we ignore these losses in the industry, but if you go by minute calculations, the losses occurring in the cable terminations also forms a major part of the total losses of the industry. So cable joints, although a small thing, but it has to be very accurate as far as safety is concerned, as losses are concerned. Then crimping should be done in such a way that the current density should remain constant throughout the path of the current, otherwise hot spot will develop and that will result into the increased resistance and the voltage drop. Increased resistance means there will be a power loss, and voltage drop means it will be resulting into the voltage fluctuation. Now if we under pressurize a crimp, it may result into the loose connection, and if we over pressurize the crimping, then it will result into the lug deformation. So it is basically a very skilled job and it has to be done by the skilled people. So that's a key point. I have just shown some of the photographs, they are taken from the industry only. So you can see first thing, there is a lot of dust on the joints, and then some heating has taken place. That blackening shows that there is heating, and that's resulting into the power loss. So this kind of workmanship is not desirable in the industry. Now coming to the sizing of the cables, because they are the main part which are carrying the power in the industry from one equipment to another equipment, or from distribution board to the different kinds of the equipments. So if the cable is underrated, then what will happen? It will be overloaded most of the time, and it will result into the heating of the cable. So even sometimes a number of accidents they are happening because of these reasons, that the cables they are not properly sized, and moreover it results into the power loss. So undersize of cable results into overheating. So the cable should be properly sized, because if the resistance is less, like say the cable is of higher size, then the resistance will be low and the voltage drop in the cable will be less. And moreover, we should keep the transformer near the large load so that the power can be supplied with high tension copper cable, so that I scale losses are less. Then minimizing the usage of voltage regulators. Now there are very small LT voltage stabilizers, they are used in the industry to boost the voltage at the load end. Tail end means we are talking about the equipment end or load end. Now whatever stabilizers we have installed to boost the voltage, they themselves consume power. So it means if you have used those equipments in the industry to improve the voltage profile, at the same time you are resulting into the power loss, and the equipment they consume around 4% of the energy. So it is recommended that to use the centralized voltage correction equipment at one place, like a high tension stabilizer, buck boost transformer, or transformers with on-load tap changers. So instead of going for small stabilizers in the industry, there should be correction, voltage correction done at one level. We can use a high rating instrument and some other buck boost transformers or on-load tap changers. Voltage controller for the lighting. Now there are number different types of lighting systems used in the industry. So one thing is that for the energy efficient lighting systems, the lighting should be task oriented lighting, like the lighting which is used on the say lathe machine. A worker is working on the machine, there may be some high accuracy is required, and then some particular light with a high CRI color rendering index is required. But in the outdoor yard, we don't need that quality, that high CRI. So we just put high pressure sodium vapor lamps or so that the lumens are high and input power is less. So efficacy is high for those instruments. Second thing, that when the lights they are on for a longer time, there is an energy limiting device which consists of auto transformers. So what is the purpose? That it reduce the voltage and current to the lighting circuit by 10 to 20%. Now when we reduce the input power to the lighting circuit, no doubt the output of the that luminaire that lighting source will be reduced, but that light output reduction is only 5 to 10%, but the power saving is 30%. And even the we are using those kinds of energy limiting devices, the payback period is 2 to 3 years. So this one option for the energy efficient lighting in the system. So first is energy go for the task oriented lighting, then we can limit the input to the lighting source. Then moreover there can be some occupancy sensors also, that if there is nobody in the room, the light should be switched off, or some kind of arrangements can be done that like say during the evening we don't need the light as it is required during the process. So some lights they can be switched on, some switch off types arrangements can be done. So nowadays a number of devices are available which switch off the light when it is not required. So some kind of programming can be done as per the requirement, like we say that at this time this light should be on, or at this time light should be off. So that kind of arrangement can be done. Harmonics, I think you had already a lecture on the power quality and all. So harmonics are a major problem for the industry and they result into the power losses. Since we are talking about energy efficiency, so I will be taking the main drawback of the harmonics is that they result into the energy losses. So to filter the harmonics, we can use the active passive filters. And when the harmonics exist in the system, then we have to derate the transformers, and the neutral conductor it should be oversized so that these equipments they don't become underrated, and there should not be any unnecessary heat losses in these equipments. And it is better to use a separate neutral conductor for non-linear loads, and avoid sharing neutral conductor wherever it is practical. So instead of using same neutral for all the equipments, it's better that wherever we have the non-linear kinds of loads, use a separate neutral so that it doesn't affect the other equipment of the industry. Then there is a maximum demand controller. When we did the types of the tariffs applicable to the industry, then there is one component of the tariff that is the maximum demand charges. So industry has to maintain the maximum demand in the limit as specified by the utility. So there are maximum demand meters which are being installed. So whenever the demand exceeds and that stays for a period of 30 minutes, so that the demand is recorded and the industry has to pay penalty for it. So for to avoid that component, then we can go for the maximum demand controllers. So what they do, we can just program them. We can just segregate the essential and non-essential loads, so that when the load of the industry is high, say there is a peak load, there may be certain loads which can be put off at that time without affecting the production of the industries. So that kind of programming is done in the demand controller. So whenever the load tries to exceed, it gives the alarm and all, and sometimes automatically switch off the non-essential loads. So that way the industry can avoid the maximum demand charges which are very high to the utility. So that is cut in the electricity bill of the industry. So after the demand has gone down, the loads which were switched off earlier, they are automatically restored. So then there are recording and metering features, they are given in the maximum demand controllers. So this is one of the equipment which is used by the industry to keep a tab on the maximum demand of the industry. Coming to the electric motors, I think induction motors, they are the workhorse of the industry. So there are different kinds of motors. We have the DC motors, we have the AC motors, and in the category of AC motors, we have the synchronous motors, then induction motors. Then again coming to the induction motors, we have three-phase motors and single-phase motors. And if we talk about the three-phase induction motors, we have a squirrel cage and wound rotor induction motors. And the most commonly used motor in the industry is the three-phase squirrel cage induction motor. That's why we call it as a workhorse of the industries. Now there can be huge savings which can be achieved by using higher efficiency motors and adopting energy efficiency measures. So since electric motors, they are the major source of energy consumption in the industry, so I shall be talking about the energy efficient technology and the way we can operate the motor in a energy efficient manner. So that will be discussed into detail. Starting with the fundamentals, the induction motor has one thing, that it never runs on the synchronous speed. There is always a slip, and slip is the difference between the synchronous speed and rated speed divided by the rated speed. And if we draw the speed torque characteristics of the induction motor, and we have drawn two curves here, full load stator current with the speed of the motor, then we have drawn the torque, speed torque curve of the motor. So at the time of starting, we can see at this time of starting the torque is low but current is very high. At the synchronous speed, the torque is at the synchronous speed, torque and current, both of them are zero. And here, when the torque is maximum, the current drops. So this is the basic speed torque characteristics of the induction motor which are used in the industry. And these concepts, they are used to decide the energy efficient operation of the induction motor. Now coming to the losses in the induction motor, we have two categories, no load losses and the load losses, or losses which occur when motor is under operation. So no load losses, they are again of two types. One is the core losses, another is the friction and windage losses. What are the types of core losses? We have the hysteresis losses and the eddy current losses. So they constitute around 15 to 25% of the total losses, and they depend on the type of magnetic material used to form the core. So once the motor is designed, these losses will occur continuously whether motor is loaded or not loaded. Then we have a friction and windage losses. They are 5 to 15%. So that is friction in bearings and all. So that the fan we use for the cooling of the motor and all. So these losses, they occur at that part. So it depends on the size and design of the fans and the kind of bearings which are used in the induction motor. Then we come to the ohmic losses or heat losses which occur in the motor when it is operating. We have a stator I square R losses. So it means these losses, they depend on the current as well as the resistance. So current depends on the load. If load is high, current will be high, loss will be more. Resistance, it depends on the type of the conductor chosen. Say it's a copper aluminum, then it's a difference in the resistance, and moreover the size of the conductor. Even if it is aluminum, it depends on the resistance, it depends on the size of the conductor. So higher size means lower resistance, lower loss. Then the same losses, they occur in the rotor circuit also, because both the circuits, they contain the windings. Then we have the stay and load losses. Different standards, IEEE standards or some IEC standards, they give the different methods to measure the stray load losses. So some standards says that 0.5% of the total input can be taken as a stray load loss. So you can see that even this is one of the major component of the stray load loss, and it depends on the design of the machine. So the most optimal design means stray load losses will be reduced. The kind of slots are used, the kind of windings are used, and all decides the stray load losses. And if we see the performance characteristic of the electric motor, this is a graph between the efficiency and the load, and then power factor and the load. So we have seen that the efficiency is around maximum around 60%. Normally it is 75% of the load. And as the load goes down below 50%, the efficiency of the motor also goes down. So most of the motors, they are designed to have the maximum efficiency at 75 to 80% of the load. Even if you see the power factor, what we have observed that the power factor also goes down with the underloading of the motor. At the time of the starting, the power factor is very poor, but as the motor picks up the load, the power factor gets better. So it is maximum at the full load conditions. But as the load goes down, power factor also goes down because of the magnetizing component of current, which is very high in the case of induction motors as compared to the transformers. So during low load conditions, magnetizing components plays a major role and power factor is poor. The factors which influence the efficiency of the induction motor are the type of the motor. We have discussed squirrel cage and the wound rotor induction motor. Squirrel cage induction motors, they are more efficient than the wound rotor or slip ring induction motors. Then speed, higher the efficiency, higher the size of the motor, higher will be the efficiency of the motor. Then the type of enclosure used for the motor. Totally enclosed fan cooled motors, they are more efficient than the screen protected proof motors. Then it depends on the temperature conditions also. Very excessive temperatures, they result into the lower efficiency of the motor. Then rewinding, if we go for the rewinding of the motor, it results into the lower efficiency. Then load, whether it's a fully loaded motor, partly loaded motor, that decides the efficiency of the motor. Then age, over the period of the usage of the motor, there may be inadequate lubrication, then there may be excessive high temperature, corrosive environmental conditions. So they result into the poor performance of the motor with the period of time. Now we come to the see that what are the energy efficiency opportunities available with the operation of uh, electric motors, and we are talking about the three-phase induction motors. So these are certain parameters. If they are taken into care, they result into the energy of efficient operation of the motor. So one is reduce underloading or avoid oversized motors. Then size to variable load. Then improve the power quality. Rewinding, it should be avoided. Then power factor correction by the capacitors. Then improve maintenance, speed control of the induction motors, and then using the energy efficient motors wherever it is applicable. Now I shall be discussing each point into the detail, that what do we mean and how we can look for the energy conservation in the energy efficient operation of the motor. Now, what are the reasons for the underloading? So, what do we mean by underloading? Means motor is operating at part load. And we have seen the characteristics of the efficiency versus load, that as the load on the motor decreases, the efficiency of the motor decreases. It is maximum around say 75% of the load. So, what are the reasons that why the motor operates under loaded? First thing, when the designer chose the motor for a particular application, he took the large safety margin, because everybody wants to play safe, but they don't understand that by choosing a large size motor may result into the poor performance. So one thing, that while deciding the size of the motor, we took a large safety margin. And even this is the case that some of the industries, like large industries, they have spare parts and all, so that inventory is there. So if we choose a particular kind of motor for particular kind of application, they have to keep the spare parts for that motor, or sometimes spare parts, they are difficult to arrange for that particular motor. So they go for the standard sizes of the motor, so that inventory can be kept to the minimum, without realizing that if we use the standard motor instead of like a job oriented or specific to the particular condition, it will result into the poor performance. Second is underutilization of the equipment. Say there is a late machine and then there is a one small deep cut for which we need a higher rating. Now it with the whole process need that point just for a second, but we have sized the equipment according to that maximum condition. So it means most of the time the equipment is operating under loaded. So that is one of the problems. Then there may be conditions and there are a lot of voltage fluctuations and we want to keep our output at the same limit. So when voltage is less, what happens? The current goes high. So some of the designers, they choose for the higher size motor so that even the voltage is low, the efficiency or the process can be maintained, although it will be done at a lower efficiency. Then some of the times the process is such that we need a high starting torque at the high starting torque. So during operating conditions, the operating torque may be very less, but since starting torque is high, we chose a motor with a high starting torque. So there are certain motors which are designed in such a way that they have a high starting torque and then operating torque is less. So when we have to decide a particular type of the motor, we need to understand what is the complete process. So what is the power system requirements, only then decide the type of the motor used for the applications. So what happens if it is underloading? We have already discussed, it will result into motor losses, efficiency will be poor, and we have seen from the curve that even the power factor goes poor as the load on the motor decreases. So it means there is no fun in choosing the oversized motor. And when we say motor loading, it means actual operating load of the motor divided by the rating capacity of the motor. So whenever we are using the term motor loading, this is what we mean by motor loading. So what we should do? Replace the motor with a smaller size, because if we already there is a oversized motor in the industry, that needs to be replaced. But replace the motor if the motor is operating most of the time at a load less than 50% of the load. So then just replace that motor with the appropriate size. But if the motor is operating at the load of 60 to 70%, then we may not go for this option. It may not be very economical, viable option. The other option available is this, that operate the motor in a star mode. Most of the motors, they are delta connected. By just reconfiguring the motor terminals at the terminal box, just convert the delta connection to the star connection. By this the voltage will go by 1 by root 3. So there will be the reduction in the voltage and the size of the machine. So it means now the operation of the motor will become more efficient. But again we have to take care that this type of arrangement should be avoided if the motor is connected to the production facility where output is related to the motor speed, because not only voltage, even the speed of the motor reduces. Now if speed reduction is not as per the production process, then we should not go for this option. Sizing to the variable load. So sometimes I just give you an example that there is a high anticipated load, even it may be required only for a fraction of the complete load curve or duty cycle, but we choose the size of the motor according to that. It should not be done in such a way. In here we can take a bit of the risk. There is a service factor, that is the overload factor of the motor. So let the motor operate at the overload condition for that moment instead of underloaded for most of the time. So choose the service factor of the motor appropriately as per your duty cycle required, as per the load requirement. So it means motor will be only overloaded for a bit of time. Now when the motor is overloaded, it will result into the temperature rise. So we find out that the average temperature rise, it should remain same whether it's overloaded or it is operating at the full load conditions. So that average temperature rise should remain same. If that average temperature rise is same, then we can go for the service factor and motor can operate for a certain part of the duty cycle at the overload conditions. But this kind of condition, this kind of option should be avoided if there are extreme load changes. Load is frequently changing. So if the load is frequently changing or frequent on off motor is occurring, then what happens? We can't find out what is the average temperature rise of the motor, or there may not be sufficient cooling time for the motor available. So there are certain options available for the energy efficient operation, but again it depends on the production facility, it depends on the duty cycle and the load requirement. But yes, there are certain options available which can be exercised by the energy manager or shop engineer or utility engineer to have an energy efficient operation. Then what is service factor? Basically it's a safety margin and it refers to the motor's ability to continuously deliver horsepower beyond its nameplate rating under specified conditions. And the motors, the service factor varies from 1 to 1.15. It means 15% of the overloading is permitted. And the energy efficient motors, they have the class F insulation and designed with a service factor of 1.15. Now the next point was improving the power quality. Motor performance is affected by the poor power, that is if there are fluctuations in voltages and the frequencies, then the operation of the motor will be affected. We just see a small analysis that say there is a three-phase motor and we have taken the three cases. Say there is a voltage unbalance. What does voltage unbalance means? The voltage of all the three phases is not same, so that is voltage unbalance. So we have taken the example of three cases. So in case 1, say there is a voltage balance of 0.3%. Due to the voltage unbalance of 0.3%, there is an unbalance in the current which is 0.4%. Then there is a temperature rise, it will be 0 degree, it will be like within permissible limits. Now if you see the voltage unbalance has become 2.3%, then unbalance in current is 17.7% and temperature rises 30 degrees Celsius. So even a small change from zero point 0.3 to 2.3, a lot of difference has made to the temperature rise as well as the current rise in the machine. And if the voltage unbalance is 5.4%, then current unbalance is 40% and temperature rise is 40. Now if the temperature rise occurs in the machine, then what happens? It affects the insulation of the motor. So it's normally said that the winding insulation life is reduced by 1/2 for each 10 degrees Celsius increase in the operating temperature. So as the temperature rise occurs, it will affect the insulation of the machine. What are the common causes of the voltage unbalance? This is the common problem of any industry. So first thing, that unbalanced supply you are getting from the utility, then tap settings are not appropriate, and there is a large single phase transformer on the system, and open phase on the primary of a three-phase transformer on the distribution system. So that results into the unbalance of the remaining two phases. Then there are certain faults which are occurring on the power transformer. Then there is the unequal impedance in conductors of the power supply wiring. Then unequal distribution of the loads on all the three phases. Now when we have to distribute the loads to the different equipments in the industry, it should be done in such a way that the three phases on the secondary side of the distribution transformer, they are equally loaded. So if the loading is not equal, it will result into the unbalance. And it may happen that the high reactive load is on the single phase load is connected on one phase of the transformer. So that will result into the unbalancing because there is not equal distribution of the loads. The nature of the load is also not same. Some of the highly reactive load is put on one phase of the transformer. So these are certain things due to certain fault conditions or due to unequal distribution of the load on the three phases of the transformer, it results into the unbalance. Now the power quality, it needs to be improved. The voltage unbalance should be kept within 1%. So what are the options available? And this is actually adopted by the industries, that balance the single phase loads equally among the three phases. Second thing, segregate single phase loads which disturb load balance. Now there may be certain loads that which if we apply on the three phases, they are not getting balance. So segregate those loads and they should be like fed by the different line or different transformer. Then there should be a power factor improvement at the load end, so that will be discussed into detail. Then minimize the cable voltage drops. That's why we discussed earlier that cable sizing, it has to be appropriate because it results into the voltage drops. Rewinding. Most of the industries, like 50% of the motors, they are rewound motors. Over a period of time, during certain fault conditions, say the motor winding is burnt. So instead of replacing the motor, first thing done by the industry is go for rewinding of the motor. Now, if the rewinding has to be done, then we have to see that the motor efficiency is not reduced. We should go for the certified firm instead of going for any kind of the organization which will rewind the motor. There should be a motor where the proper, we should go for the firm where the proper testing, all the facilities are available. And it's better that see the test certificates of the motor which were obtained at the time of the buying of the motor, original test certificates. Now they should be compared with the test certificates obtained after the rewinding of the motor, and we should compare the thing. We should see what was the no load current of the original motor and what is the no load current of the motor after the rewinding is done. So if it is within acceptable limits, only then then use the rewinding motors. Otherwise, don't use the rewinding motors. It will result into the loss. So if we just do the payback period analysis, that after rewinding the efficiency goes down, what will be the loss occurred during the operation of the motor, and if we replace the motor by the new motor, a new motor has to be energy efficient motor, then that payback analysis can be done. So buy new motors if the costs are less than 50 to 65% of the rewinding cost. So this is one of the things. There are certain thumb rules that if this is the case, then go for new motor, or if this is the case, then go for the rewinding of the motor. I have put at another slide that how the losses occurs with the rewinding of the motor. Now next is improving the power factor. So what's the importance of the power factor? Why electrical people they talk about the power factor is concept than the improvement of the power factor. So what happens that if the power factor is poor, power factor poor means the reactive power drawn by the system is very high. So kVA is basically kilowatt square of the active power, and the reactive power and is square root, that is your apparent power or kVA input of the motor. So power factor poor means the reactive power drawn by the system is very high. So kVA will be high, current flowing in the circuit will be high, and if current is high, then what happens? Ohmic losses will be high, voltage drop will be high. So losses high means poor efficiency, voltage drop means it will affect your system performance. So it means we have to increase the efficiency of the system, means the power factor should be improved. The power factor can be improved by using the capacitors for the induction motors, because induction motors they draw magnetizing current from the supply. So operating power factor is not very high for the induction motors. So when we say the power factor of the industry is poor, most of the time the most cause is the of the operation of the induction motors. Although some of the welding cells like those furnaces they also result into the poor power factor. Even lighting loads they are also poor power factor loads. Now when we have to decide the size of the capacitor of the for improving the power factor of the induction motor, one is very clear that the size of the capacitor should not be more than 90% of the reactive power required by the motor at no load conditions. It should not increase. Otherwise, what will happen? That it will result into the transients. It will result into over voltages. If the capacitor rating is high, when the power factor of the motor is high, so it means it will be overdone. Overcorrection of the power factor will be done, and that results into the over voltages, which is again a harmful situation. So I have just put one table is taken from the Bureau of Energy Efficiency. So this table just shows that if the size of the motor changes, and on x-axis like we have taken the speed of the motor. So then what is the requirement of the reactive power of the motor? Say it is a 5 HP motor. If it is 3000 rpm, then 2 kVR is required as the capacitor rating, and as the speed of the motor decreases, the capacity requirement of the capacitor, reactive power requirement of the capacitor decreases. So these are there are certain tables which are available from where the designer can choose that okay, this is the size of the motor, and this should be the size of the capacitor bank which has to be used for switching the induction motor in the industry. This is just one example. I hope that if it is clear to you, the diagram is basically capacitor switching of the induction motor. Now there are three cases that where the capacitor should be put. One is capacitor should be put in the near to the terminals of the motor. What will happen? That the capacitor is put in shunt to the motor. It means the reactive power drawn by the motor will be taken from the capacitor instead of taken from the utility. So the reactive power which had to flow from the utility from the switchboard to the motor from the through the distribution network, that will be reduced because we have met the reactive power requirement of the motor locally through the capacitor bank. Now there are the three different positions of the capacitor which can be put across the terminals of the motor. So first, this is the capacitor A. I just see this is location A. It is ideal for new installations so that the thermal overloads can be sized to match the reduced current. So if any new installation, it should be kept here. And in second case, we have a capacitor B, and this is between the starter and overload relay, and it is meant for the existing motors. Motor is already in operation, and now you have to put the capacitor switching of the motor. So all overload element, they are already sized according to the motor. So it means now we have to just put before that. And the third case is that there are frequent on off of the motors. So at that time we just put the location C, that is after the circuit breaker the capacitor switching should be done, so that if the motor is switched on off and all, it is not affecting the capacitor bank and the other equipment. So there are certain options available for putting the capacitor across the terminals of the induction motor. Now see, there are number of motors which are operating on the which are used on the shop floor. So instead of using capacitor switching for individual motor, there can be a group switching also. Like all the motors they are say fed from one distribution supply board, then we can make the capacitor bank there so that whenever the motor draws the magnetizing current is supplied by the capacitor bank, and this is usually the lowest cost installation. Then we have the intelligent power factor controllers which are available nowadays and they are used in the industries. Capacitor banks, they are used everywhere to improve the voltage profile. Voltage profile means they are used to locally supply the reactive power to the system. Now when we use at the distribution, like in the switch yard of the industry, say there is a 66 kV substation and we have used a capacitor bank there in the switch yard or substation there. What happens if we are using a capacitor bank there? It means we are not taking the reactive power from the utility. So as such, the benefit goes to the utility, that the reduction of current takes in the place in the transmission lines, and as such losses of the transmission line reduces. Okay. And second thing, when we talk about the distribution network in the industry, then we are using the capacitor banks locally at different distribution boards, so that distribution network does not has to carry the reactive power of different kinds of loads. All the different categories of loads which need the magnetizing current or reactive power from the supply, they are met locally through the capacitor banks. Then there when we are using the capacitors at different situations and all, there may be a condition that say voltage has dropped and the perfect capacitor bank has to be switched on, or when there are certain light load conditions, then capacitor bank has to be put off. So these are the intelligent power factor controllers. So they are the device which are used for the power factor corrections. Again, they are pre-programmed and we have to decide which one is first in first out or first in last out, and according to that the capacitors, different units of capacitor bank, they are switched on and switched off. So it means unnecessarily over voltage, under voltage conditions. They are avoided automatically by using the intelligent power factor controllers, and the power factor of the industry, it is maintained at the preset limit, because there are heavy penalty charges by the utility in their tariff component, and at the same time incentives are given by the utility to the industry for obtaining the power factor at a higher limit. I just quote an example of the Punjab. Here the industries, they are supposed to maintain the power factor of the industry at 0.9. Now every point 0.1 rise of the power factor above 9, there is a 0.25% rebate in the energy charges. So it means if the power factor is 0.94, there will be a 1% energy rebate. So that is a motivation for the industry to maintain the power factors. Again, capacitor banks, because they are linked with under voltage and over voltage conditions. So both the situations, like where we want to get the incentive for the power factors and we want to avoid the penalty charges due to poor power factors, that can be done with the help of the intelligent power factor controllers, which automatically switch on the different units of capacitors. Again, these capacitor banks, they provide the phase angle also, so that whenever the current is low, then they will automatically switch off the capacitors. So even that provision is available with these kinds of power factor controllers. Maintenance plays an important role. It's not true only for the motors, but I think it's true for all the equipments which are used in the industry. Even if you see the light and all, the common practice you see that lumens are less because there is a lot of dust on the tube light. So even this is one small example, that if there is a, you just clean the dust from the, lumens will increase. Now when it comes to the motors, again maintenance plays an important role, because with the proper maintenance you can get a you can get the proper performance of the motor. So even aging of the motor, the poor performance of the motor due to aging is one cause, is the improper maintenance or improper lubrication of the motors. So to maintain the motor efficiency, inspect the motors on the regular basis. There should not be any a weird dust or dirt. Then motor loads for overloading and underloading, that part we have discussed. Then lubricate the motors appropriately. If there is a excessive lubrication, means you have put a lot of oil or grease, then this grease will enter the bearings of the motor and saturate the motor insulation, causing the permanent failure of the motor or creating a fire risk. If it is not lubricated properly, it is less lubrication is there, it will result into more frictional losses. So in both the ways, means something has to be done in a appropriate manner. Higher lubrication is also a loss, and even lower lubrication is the loss. Then check the alignment of the motor and the equipment. Then ensure supply wiring and terminal box, they are properly sized and they are installed. There should be adequate ventilation to the motor. For every 10-degree increase in motor operating temperature over the recommended peak, the time before rewinding would be reduced to half. So it means now you have to go for the rewinding of the motor. So temperature rise, it depends on all those conditions. If the temperature ventilation is not proper, or the motor is overloaded, then it results into the temperature rise. So that proper lubrication, taking care of dust, dirt on the different parts of the motor, so that ventilating ducts, they are not choked. So those kinds play an important role in the energy efficient performance of the motor. Now coming to the starting of induction motor. What happens when we start the induction motor? Yes, anyone? It draws a high current, so that results into the voltage fluctuation. So when you switch on the motor, other appliances, they also get affected. So it means at the time of the starting, motor develops a high torque, high current, and that results into the wear and tear or premature failure of the chains, belts, gears, mechanical seals, etc. And the current is very high. Now what should we do for that? There are soft starters. I think most of you must have heard about the soft starters. Basically, they are the reduced voltage soft starters. It releases the control. There is a controlled release of power to the motor So there is a smooth start of the motor. Acceleration is very smooth. So this is built into 3 units, so that starting and stopping everything is done smoothly done, and there are no surges there. There are no like peak points are there. So advantages of soft start are like there will be less mechanical stress, there will be power factor will be better because it will not draw very high starting current. So power factor will not go poor, then there will not be maximum demand will not be high, because otherwise if the motors they just start and heavy current is drawn, the maximum demand of the system may increase. So that condition can be avoided and there is a less mechanical maintenance. So let's see the characteristics of the soft start. I have taken the 3 different kinds of starters for the induction motor. First is the direct online starter. We can see there is a surge of the current. The current drawn is very high when we are using the direct online starter. With the using star delta starter, there is not a surge, but when you move from star to delta position, for that movement there will be a transient. During that transient condition, there will be a peak. So thereafter is a smooth. And if you see the soft start starter, there is a smooth start of the motor. Motor is picking up the current in a smooth manner. And if we come to the mechanical stresses, there is a large surge transients. Like these mechanical stresses, they are developed with the help of the direct online starter. But if you see the soft starter, then the curve is very smooth. So mechanical stresses are less when we are using the soft starter. Coming to the speed control again, when we say load, it means we are referring to the torque output and the corresponding speed. There are the total load on the induction motor or motor can be divided into 3 categories. One is constant torque load, then we have a variable torque load, then we have a constant power load. So when we say constant torque load, it means output varies with speed, but torque is output power varies with speed, but torque is constant. So that is a constant torque load. What kind of loads are these? Like conveyors, then constant displacement pumps. They come into this category. They operate at the constant torque loads. Then we have the variable torque loads. Here the torque varies with the square of the speed and the power varies as the cube of the speed. Centrifugal pumps like fans, HVAC applications, they are having a variable torque loads. Then we have the constant power loads, means torque changes inversely with the speed but the power remains constant, and the machine tools, vibrating conveyors, punch presses, they are the examples of these kinds of loads. Now we have to see that which category of the loads gives a scope of the energy conservation or energy efficient operation, means in these kinds of load where there is a potential for the power saving. We have 3 categories: machine, constant power, constant torque, and variable torque. If you see the constant power loads, they absolutely don't have any potential for the power saving. So it means during the operation of the motor, there is no other technique which we can employ for the power saving. And here in the graph I have shown on y-axis it's energy savings and on x-axis is the speed. So if we see the constant power graph, it is just touching the horizontal axis because there is no potential for the power saving. And if we go for the constant torque, there is a power saving scope, but it's a limited scope. And if you see the graph, it's a horizontally, there is a graph with a slope. So as the speed increases, the scope of the power potential decreases. Then we have the variable torque, and this is the area where we go for the maximum power saving. So for these variable torque applications, we use the variable speed drives to go for the power saving. It's just an example that variable torque loads are basically centrifugal pump loads and all. HVAC applications, all of them, they come under the category of the variable torque loads. Here the speed varies as the square of the torque varies as the square of the speed, and the power varies as the cube of the speed. So it means if the motor runs at 90% of the speed, the power consumed will be only 73%. If motor runs at 80% of the speed, the power consumed will be only 51%. And again, if the go for the constant torque loss, they have a potential of the power saving, but the limited saving. And again, variable speed drives that are applicable for the constant torque loss also. Yeah, now let's see. When we say variable speed drive, what does it mean? Means we are talking about the speed control. Speed control is ns is equal to 120 f by p. P is the number of poles. So once the motor is designed, the number of poles they are fixed. It means speed is proportional to the frequency. So by changing the frequency, by increasing or decreasing the frequency, you can attain the variable speed above the base speed and below the base speed. So that speed control is by changing the frequency as well as the voltage applied to the motor. So by using a variable speed drive, we are basically controlling the voltage and frequency at the terminals of the motor. So this is one example of the variable speed drive. We have the simple circuit. We have a three-phase supply that gets converted to rectifier, that gets converted to DC by using rectifier. Then we have an inverter circuit, and what will be the output? It will be the variable voltage and variable frequency at the motor terminals. And if you see the graph on y-axis, I have taken the voltage. On x-axis, we have taken the speed. So first thing, there is a minimum voltage which has to be maintained. It means we can't decrease the voltage below this limit. So that minimum voltage is fixed. Then we have the rated voltage. Now we want to control the speed from the rated speed, zero speed to rated speed. Then what we do? We have to change the speed. It means, say if you are decreasing the frequency, what will happen? If you decrease the frequency, then the impedance of the circuit will decrease, current of the circuit will increase, and it will result into more flux. It means the saturation of the magnetic circuit will take place. So to avoid the saturation of the magnetic circuit, what we do? We reduce the voltage. So as the frequency is reduced, the voltage is also reduced, so that the ratio of voltage by frequency, it is kept as a constant. So as the frequency increases, voltage also increases. So up to rated voltage, this is applicable, and since the magnetic flux density in the circuit remains constant, so torque remains constant, but the power changes as the speed changes. So this region is a constant torque region. But after the rated speed, what happens? We can't increase the frequency now. Now we want to obtain the speed at a higher value. We want to take the speed higher than the rated speed. It means frequency has to be increased. Frequency increasing means the voltage has to be increased. So but we can't change the frequency. What will happen? There will be a weakening of magnetic field, and there will be a magnetic field will be reduced, so torque will also reduce. But at this speeds, some like frictional and bearing losses, they become non-linear. Their behavior changes. So instead of getting a linear curve during that region, we are getting a exponential curve. Is a non-linear curve. Now coming to the energy efficient motors. Energy efficient motors, they are designed in such a way that the intrinsic losses, they are less, their efficiency is high, there is a wide range, and they are expensive, but again we have a small payback period. And these motors, all the motors, they need to be replaced with energy efficient motor if the existing motor fails. These when we talk about the power loss, this type of table we have done for the conventional motors also. Like what is the key feature for the energy efficient motors? We have a fixed loss, again theta I square losses, ohmic losses, friction windage losses, and load losses. Now the motor is designed in such a way. Why the motor is costly? Because the kind of material is used, and the size of the material is used, and the motor designing is done such a way that overall the cost of the motor becomes high. Iron losses are less because we are using the thinner gauge. Lower loss core steel reduces eddy current losses. Then longer core adds more steel to the design, which reduces losses due to lower operating flux densities. Then we are using more copper with larger conductor size, so it means resistance reduces. Resistance reduce means losses reduce, and losses reduction means current will reduce. So as such, ohmic losses reduces, and the voltage drop also reduces. So again, it's not only the energy efficient operation by the option for the energy efficient motor. We have a extended warranty. Lubrication cycles are extended due to cooler operation because temperature rises less, and moreover these motors, they are operated with the are provided with the class F insulation. So these motors, they have the ability to operate in higher ambient temperatures because insulation class is better, so temperature rises less. Then they have the ability to handle the overload conditions. Failures are less due to impaired ventilation, and there is more tolerance to poor voltage and current shapes. So which kind of motors we need to replace? For all new installations, the motors have to be energy efficient motors, though they are expensive, but payback period is very small. If there are any major modifications are to be done, or some rewinding motors, we can instead of using rewinding motors, we can opt for the energy efficient motors, or as a part of energy management or preventive maintenance program, we can replace the old motors with the energy efficient motors. Energy savings by motor replacement is given by kilowatt output into 1 by efficiency of the old motor minus 1 by efficiency of the new motor. Energy efficient motors, there are certain constraints with the energy efficient motors. They are not available for many special applications like fire pumps or very low speed applications below 750 rpm. They are not designs are not available for multi-speed motors, and they are not suitable for highly intermittent loads or special torque requirements such as hoist, cranes and all. And they are motors, they are designed for the continuous operation only. So these are certain constraints with the energy efficient motors regarding their availability. And then we have the IEC standards, which give the different categories of the motors based on their efficiency. One is IE1. IE stands for International Efficiency. So that is the standard efficiency. Then we have a high efficiency. Then we have a premium efficiency. Then we have a super premium efficiency. So those will be a different kind of motors. These conventional motors can't, maybe not fit into that category. So if we see that, it means perfect shall be improved, and repeated rewindings of the motor, it should be avoided, and we can use the variable speed drives as far as all these motor operations are concerned. Now I just come to the compressor systems, and I just take a, I think we are getting short of time. So I just talk about this. We were talking about like electric motors and all. So now compressed air systems, all the systems, they are also consuming energy in one or other form. So we need to have an energy efficient operation of these motors. When we talk about the compressed air, now compressed air is very energy intensive. Only 5% of electrical energy is converted to the useful energy. So for cleaning purposes in the industry, we should not use the compressed air. So where you can use a simple cloth to clean the some equipment, you should not use a compressed air. Then ensure low temperature of the inlet air. So increase in inlet air temperature by 3 degrees Celsius increases the power consumption by 1%, and also reduction in discharge pressure by 10% saves energy consumption up to 5%. A leakage, a small leakage will cost you heavier, so it means one should take care that there should not be any leakage of the compressed air in the total systems. And then air output of compressors per unit of electricity input must be measured at the regular intervals. So if the efficiency, normally efficiency of the compressors, they reduce with time. When we talk about the refrigeration and air conditioning plants, the use of double doors, I think all of you understood that we have one door, another double door. I think even this room has a double door provision. Then automatic door closers, then air curtains, double glazed windows, they help into the reducing the air conditioning requirement of the building or office, because so that the natural heat, it should not come inside, so that reduces the load on the conditioning plant. Then maintain condensers for proper heat exchanges. A 5 degrees Celsius decrease in evaporator temperature increases the specific power consumption by 15%. So utilization of air conditioned space should be examined and efforts should be made to reduce cooling load as far as possible. Then utilize waste heat of excess steam to change from gas compression system to absorption chilling systems which are more efficient. Then specific power consumption of compressors should be measured at regular intervals. Energy audit of all these equipments it should be done on the regular basis. We just don't need to call the auditor from outside. It should be a regular practice by the shop engineers. And even if we talk about the cooling towers and all, then inefficient aluminum or fabricated steel fans by molded fiber reinforced plastic fans with aerofoil designs result into electric savings in the range of 15 to 25%. Then install automatic on-off switching of cooling tower fans and save up to 40% of the electricity cost. If we talk about the energy efficient operation of the pumps, improper selection of pumps as we did for the motors, same is applicable to the pumps also. If they are not sized properly, then a pump with 85% efficiency at rated flow may have only 65% efficiency at half the load, as we did for the motor also. So use of throttling valves it results into the power loss because it doesn't result into the power saving. So we should use some other speed control measurements. And again, it's better that instead of using a large size pump, put a number of pumps in series and parallel so that as per the requirement you can switch on off pumps. Then drive mechanism between pump and motor is very important. So loose belts they can cause the energy loss up to 20%. Then properly organized maintenance is very important. Efficiency can drop by 10 to 15% by improper or poor maintenance or proper check. Coming to the furnace, plug oil, all oil leakages. That's the main thing because sometimes after you visit the industry and all, some leakage is taking place and all. So that results into the unnecessary power loss. Then filter oil in stages, impurities affect the oil, affect the combustion. Then preheat the oil. For proper combustion, oil should be at right viscosity at the burner tip, so there should be a preheat. Then incomplete combustion leads to the waste of the fuel. Like if you observe the color of the smoke coming from the chimney, black smoke indicates that is a incomplete combustion. If it is a white smoke, it means there is a excess air. Again, that's a cost. Then hazy brown smoke, it indicates that the combustion is being done properly. So that's the main indication of the combustion of the fuel. Then use of low oil air pressure film burners, they help in saving the oil up to 15% in the burner. If we come to the energy efficient operation of furnace again, every 21 degrees Celsius rise in combustion air temperature results in 1% fuel oil savings. There should be a control of excess air in furnace. We have stated that if there is like smoke, white smoke, it means there is a excess air. Then reduce heat losses through the furnace openings. That is a complete check for even the compressed air systems also for the furnaces everywhere. Then improve insulation if the surface temperature exceeds 20 degrees Celsius above ambient. And proper design of lids of melting furnaces and training of operators to close lids helps in reducing the losses up to 20%. When we see about the boiler, what is the problem of scaling? So remove soot deposits when flue gas temperature reaches 40 degrees Celsius above the normal. So recover heat from the steam condense. So that is energy efficient operation. For every 6 degrees Celsius rise in boiler feed water temperature through condense return, there is 1% saving in the fuel. So improve the boiler efficiency. So boiler should be monitored for flue gas losses radiation losses, incomplete combustion, blowdown losses, excess layer. So proper control can decrease the consumption up to 20%. Use only treated water in boilers. A scale formation of 1 millimeter thickness on the water side would increase fuel consumption by 5 to 8%. Stop steam leakage. Steam leakage from a 3 millimeter diameter hole on a pipeline carrying a steam of at 7 kg per centimeter square would waste 32 kiloliter of fuel per year, amounting to a loss of say 3 lakhs. Then maintain the steam pipe insulation, and say there is a bare steam pipe 50 millimeter in dia and 100 meter in length carrying a saturated steam at 8 kg per centimeter square would waste 25 kiloliter of furnace oil in a year, amounting to a loss of 2.5 lakhs. So it's the last coming to the DG sales. Again, all the industries they are having the diesel sales. So the operation should be proper, efficient, and the maintenance of DG sales uh, is very much mandatory. So if there are any questions or you want to ask anything, please do ask. Of the DG set, so that maintenance needs to be done. So that was all from my side. So we are open to any queries or anything you want to ask. Actually, each topic itself is a vast topic. So complete like one lecture can be held on say cooling system or lighting system or motor systems. So it was just a brief of that what kind of energy efficient measures can be taken in the industry to save energy, to save the fuel, to reduce the electricity cost, to reduce the carbon footprints, I would say. So the benefit doesn't go only to industry, but as such it goes to the society because overall the power requirement reduces. So if there are any questions or you want to ask anything, please do ask.
मैम जिस तरह से आपने बताया था मैम कि इंडस्ट्रीज में ऑफ लॉस में अगर लोड ज़्यादा है वो तो टैरिफ के रेट उस हिसाब से अकॉर्डिंगली हाई होते हैं इनकेस अगर बात करें हम किसी एरिया की पर्टिकुलर जहाँ पे पब्लिक रेजिडेंशियल एरिया में तो वहाँ पे क्या ऐसा नहीं सिस्टम है
Actually, sir, nowadays the country is moving towards the time of day tariff. So time of day tariff means the tariff applicable to the consumer, whether he is a domestic consumer or is an industrial consumer. It depends on the power scenario at that time. If you are drawing the power, say you are drawing 5 kilowatt at your residence at a peak hours, at that time tariff applicable will be high, but during off peak hours tariff will be low. So certain things are being under the implementation stage. So there are even some tariffs they are changing from state to state in the country. Although there are certain regulatory commissions, but they are changing. Worldwide, in many of the developed countries, they are already opted for these systems.
Hello. Hello.
Hello?
Good morning, ma'am. And this is
Good
from
morning.
various group of institutions. Ma'am, I just want to ask, is there any significance of using 3-star or 5-star rating transformers in case of power transformers?
In case of?
Power transformers.
Sir, actually, star labeling is done by Bureau of Energy Efficiency for the distribution transformers, and star labeling means higher star rating means the losses will be less. So if you are using a higher star labeled, like say 5-star labeled transformer, then no doubt the losses will be less. But it is done only up to a certain rating. I think it's 1600 kVA.
Okay, ma'am. Thank you, ma'am. Thank you, ma'am.
Hello, ma'am. As you have said that for derating of transformer, derated transformer for reducing harmonics, ma'am, is there rewinding is necessary for derating the transformer or any other method is there?
Pardon, sir, I couldn't get you. Is the derating of transformer during harmonic conditions?
Yes, ma'am.
Actually, there are different methods to derate the transformer. One is like crest factor. So there are certain ratings, like there are different kinds of formulas for which we put the phase values, RMS values, peak values, and RMS values. Then accordingly we find out the derating factor. So that derating factor is applied to the total capacity of the transformer. So it means if it is say 1000 kVA, but only we have to rate it for 800 kVA. So that 200 kVA takes care of the increase of power due to harmonics. So that is meant by derating of the transformer, if this is the question.
Okay, ma'am. Thank you, ma'am.
If there are no more queries, thank you so much. Thanks for the patient hearing. Thank you so much.
So thank you, Dr. Singla, Dr. Anil Singla, for giving us very nice talk on energy efficient technologies being used in industries. And I believe people have enjoyed it, and she has answered your queries also. So that's a wonderful session. Now there'll be a tea break for about 20 minutes. It is 11:10 now, and we will assemble here at 11:30 sharp. And let me remind you, all of you, that the valedictory session will be at 2 o'clock sharp. And our director has agreed to join the valedictory session here. So you all should be here right at 2 o'clock, right? 2 o'clock sharp. And it will go for about half an hour or 45 minutes. So be here with us, and then that will be the end of this course. Thank you so much. So we meet here at 11:30. Thank you.
तो जानते हो और स्क्रीन पर आ नहीं रहा है।
So welcome back to the last session of this course, and so far we have talked about the significance of energy, specifically the electrical energy. We have also talked about renewable energy sources. We have also talked about energy audit, the energy conservation, the different techniques for energy conservation, the different techniques of energy audit. We have also worked out some of the case studies about energy audit, etc. And today we have also talked about the technologies, energy efficient technologies, because I have been telling you that the paradigm shift is from energy intensive technology to the energy efficient technology. One is how to save energy by conserving. That is one technique, simple. One is you can decrease the demand, but that's not a healthy sign. I have already discussed with you. So let the demand increase. That shows that is a very healthy sign, and that shows the progress of technology, progress of application of technology, and improvement in the daily life. That is lifestyle. So the quality of life also increases with adoption of technology. So once you adopt the latest technologies, naturally the energy associated will be maximum. It will be more. So there is no harm increase in demand. It's rather a better sign. It's a good positive signal it is. Now once the energy adoption or the application or the usage of electrical energy specifically is increasing, so as I say, it is good. So how to make the situation balanced? Either you increase the supply or you decrease the demand. So don't go for decreasing the demand, let it go high and high with a very high pace. But what to do about the pace of supplying it, matching it to the supply? That's a very, very difficult task. And perhaps that is not very easy for you, for the government of India, for the private sectors also to introduce such heavy demand. So there comes the next solution, the best possible solution, that is energy conservation. So one part, as I have already told you, the main aspect of energy management is energy conservation. The other aspect is also equally important, that is to know the status of the system, state of the art, and that is through energy audit. So on the whole, when you make energy audit for knowing the state of the art of the system, and also you know how to conserve energy, you manage the system. The umbrella is energy management. Now, there are certain case studies we have given you about street lighting, about electrical equipments, instruments. I have already given you some case studies about laboratories or industries, your different premises, etc., etc. And you can also take up a small project related to your home, house, because charity begins at home. And nothing succeeds more than success. These are the two mantras you can always have in your mind, that charity always begins at home and nothing succeeds more than success. So you will definitely succeed if you have some success at your home. That is the best starting. And then later on you have to follow. So today in this session also, I will discuss with you the waste heat recovery from automobile. This is a very, very important case study, and this was done by one of my friends who was that time doing PhD in IIT Delhi. The person who has given these data for me, which I will share with you, is known to me, that is Dr. Khatri, and he was doing his research in IIT Delhi while doing his PhD. So he is a man, first of all, he did diploma in automobiles. Then he came out as a very practical person. He came out with the degree that he did from Delhi College of Engineering in automobiles. Then he did masters from IIT Delhi, and finally he did his PhD also. He acquired his PhD degree in the sector of automobiles from IIT Delhi. And the state of the art for this person is that इवन जो दिल्ली के मिस्त्री वगैरह होते हैं जो ऑटोमोबाइल्स के, वो उनके पास जाते थे कोई प्रॉब्लम अगर द मैन इज अ हाईली प्रैक्टिकल मैन. सो दोज डेज व्हेन ही वाज pursuing his PhD work, he did a very little small project, an experimental project, which I would like to share with you, and that shows the significance of conversion of heat energy into electrical energy in the automobile sector. So this is the topic what we are going to discuss in this session. The transport sector, very, very important sector. Now, why I have taken this case study? There is a reason, solid reason behind it. I have given you case studies regarding street lighting. I have given you case studies regarding planning installation of machines in electrical or mechanical workshops. I have given you case study for taking up equipments. How do you save energy? That is your main objective. So transport sector is another sector wherein there is a possibility of saving energy. That's why I have taken up this example. It says transport sector losses very, very high. You will be surprised to know that in the transport sector, the losses are in the range of 65 to 70%. It is not the efficiency, it is the loss. So what is the efficiency? Efficiency is only 30 to 35%. Can you tell me why so much of loss in the transport sector? क्या कारण है? What kind of transports are there in this country? Tell me. Road transport, rail transport, ship transport, and air transport. These are the four major transports we have. So road transport is mainly through trucks and lorries and jeeps, etc. So that takes the automobile sector. In the railways also you are using diesel as the fuel for transporting your goods trains. That is the transport sector in railways. In air also you are using petroleum product. In ship also you are using petroleum product. So there is an abundance of use of your fuels for transporting one good from one place to another. And that says that the efficiency is very, very low, the losses are very, very high. तो यहाँ भी जब आप देखते हैं डीजल इंजन हो चाहे पेट्रोल इंजन हो, पेट्रोल इंजन efficiency is little better of course, that is used for mainly for passenger transports. But for goods, which is main I use is diesel, right? High speed diesel, HSD they call it. जिसकी की वैल्यू जो है MCT अगर आप मिलियन टन्स ऑफ कोयल में देखें तो इट इज नॉट वेरी हाई. तो व्हाट इज हैपनिंग? व्हाई द लॉसेस? आप देखे होंगे कि डीजल से कितना फ्यूज, ब्लैक फ्यूज निकलता है. सो लॉसेस आर इन द फॉर्म ऑफ हीट and also in the form of flue gases. So heat is one thing which is converted from the engine, any kind of engine, and the transmitted power is very, very less. The transmitted power which is doing the useful work is very less, and lot of it is lost in the form of heat. And that gives you two disadvantages, main disadvantages. Number one is the loss, that is fuel wastage. And number two is the pollution of the atmosphere. So we have also talked in detail about the pollution part. You want to have clean energy, green energy, is it not? Green technology is the talk of the day, and green technology means don't burn fossil fuels, minimize it as far as possible, as much as possible. So if you are continuously burning the fuels, the fossil fuels like coal, like wood, like petroleum products, like that, so you are using them, you are depleting the storage, and at the same time you are creating lot of atmospheric pollution. दोनों ही चीज खराब है. Both the things are very, very bad, and you will be surprised to know that these flue gases in the form of NOx, COx, SOx, they are causing lots of diseases. There is a very big ecological imbalance because of cutting of trees and because of using these fuels and burning these fuels. So you are landing where? You are definitely trying to generate some power, electrical power, but that amount of power which is generated is at a very, very huge cost of human beings, of atmospheric pollution, of losses, etc., etc. So that is the point wherein I got very much interested in taking up this case study, and I want to discuss with you. The causes of wastage of heat, in turn, environmental pollution. जो हीट टर्न होता है उसी से फ्लू गैसेस बनते हैं, उसी से स्मोक्स बनते हैं, और उससे पोल्यूशन होता है. द फ्लू गैसेस आर NOx, COx, SOx. These are known flue gases, and they are very dangerous, out of which the COx group is the most dangerous group. The sulfur group is also dangerous. The NO is also dangerous, but the most dangerous is the COX. So carbon monoxide, carbon dioxide, etc. are the biggest enemies of human beings. So you have to curtail it, and that is the point of concern. When so much of this thing is wastage, the transmission power is so less, you are creating so much of environmental pollution. What is the objective? And that is why many people are against this generation process. There are many, and they have the valid reason also. Definitely it should be. So you have to go in for other technologies which you have already discussed, which is renewable technology, and that is in force, and you have to do something for achieving that technology in future. Almost 1/3 of total heat is carried out from the exhaust gases. This is a point to be noted. अगर आपने देखा होगा कि आपके पास स्कूटर होता है, you have scooter, 2-wheeler, you have 4-wheeler, स्कूटर में जो आपका जो गैस पाइप है, जो एग्जॉस्ट है, उसको कभी अगर आप हाथ लगा दे बाई चांस, आपके हाथ में बर्न्स हो जाएंगे, फफूले पड़ जाएंगे. कैन यू इमेजिन व्हाट, पैर लग जाए तो उस पर फफूला हो जाएगा. कैन यू इमेजिन व्हाट इज द टेम्परेचर देयर? Why is the temperature so high as the exhaust pipe? Why the temperature as the radiator of your car is so high that it needs lot of water to be poured to cool it? Why? Because lot of transmission losses is taking place in the form of flue gases, and it is generating lot of heat, and that is exhaustion fluid. So exhaustion means dissipation of heat, dissipation of flue gases. Both are very, very bad. Efficiency goes down, at the same time the atmosphere gets polluted. So this is a point of attraction. This is a very, very alarming situation. Let us try to do what can be there for improving the transport sector. The transport sector uses, it is one of the biggest users of your fossil fuels, and it creates a havoc so far as the atmospheric pollution is concerned. Distribution of heat energy in automobile engineering. Now let us see the automobile engine. Automobile engines are used in all kinds of transportation as far as the road transportation is concerned. The exhaust gases is about 33%. 33% of the losses are in the exhaust gases. Then heat meant for cooling, that is radiator, etc., that is about 30%. VHP and FHP of the engines, they are causing about 25% and 12%. So that makes 100%. If you take 100% the losses, the distributions are like this, which is shown in this graphical bar chart. So it is exhaust gases in radiators, VHP and FHP, 30%, 35, 33%, 25% and 12%. So that is an alarming situation. Try to understand that this is very, very important, and what you can do as an engineer, as an environmental engineer, as a civil engineer, as an electrical engineer, as an electronic engineer, and as a mechanical or automobile engineer also. Let us see. So by this concern, as I am concerned, there I said my friend Dr. Khatri, he got concerned and he did a very basic experiment. He conducted a very basic experiment during his days of pursuing PhD in IIT Delhi. The experiment was on an 800cc Maruti car. Now this is very interesting. Since he was a very bright student, a very bright PhD scholar, the Maruti car actually sponsored his PhD. So he approached the Maruti company and they sponsored his PhD work in IIT Delhi. Now how they sponsored it? They gave him two cars. Two cars. Of course, those days 800cc Maruti car was very popular. So now why two cars? One car was for his personal use. He used to use it personally. And the other car was for the experimentation purpose. That experimentation purpose, that particular car which he used for experimentation was kept in IIT Delhi, in the workshop. So what are the specifications of car? As simple, 800cc passenger car fitted with 4-stroke 3-cylinder spark ignition engine. This was the main specification. Is it okay? So he was given a task to improve its efficiency. The efficiency means its fuel consumption, जिसको हम ज्यादातर क्या बोलते हैं, एवरेज, यही बोलते हैं ना, average consumption of the fuel, that is petrol, in the form of kilometers, So much of petrol will give so much of kilometers travel. That was his. Now how to make improvements in that, and he came out with lot many improvements, which is a part of the automobile engineering, which I am not going to discuss, but I am only focusing my discussion on the conversion of heat energy which was available in the exhaust into electrical energy, and the purpose is very simple. Why do you need electrical energy for a car?
Light bulb, light and horn.
Light, horn, your sound system, and then backlight, tail light, etc., etc. So many things. AC and battery charging, all those things. Ignition, everything needs electrical connection. There is a subject called electrical applications in automobile. ये टेक्नीशियंस होते हैं ना, इलेक्ट्रिशियंस एंड टेक्नीशियंस जो ऑटोमोबाइल के टेक्नीशियंस जो मार्केट में बैठे रहते हैं, उनमें एक स्पेसिफिक आदमी होता है, स्पेसिफिकल नॉलेज होता है उसके पास, वो इलेक्ट्रिकल का पार्ट देखता है. So he is very knowledgeable, technically sound in that particular area. So that finds a very, very important part. It forms a very important, significant part so far as automobile is concerned. Now let us see. क्या किया इन्होंने? The circuitry, he used a very simple circuitry. उनका objective क्या था? What was his objective? His objective was, he knew that the exhaust pipe is very, very hot. It has got lot of heat present in it, and the dissipation for no means is useless. If I can recycle that particular heat into electrical energy, perhaps I'll be able to meet the need of the car. वही उन्होंने किया था. Is a very simple experiment, but very, very useful. That's why I wanted to discuss with you. तो क्या किया उन्होंने? thermocouple use किया, J-type thermocouple. Those days J-type thermocouple was very popular, but nowadays so many your solid state, digital thermocouples are available. No one uses those analog thermocouples. What was the main disadvantage of analog thermocouples? What is the main? Anybody? I think a lot of people are sitting on the instrumentation control side. So if I ask you, what is the biggest disadvantage of an analog thermocouple?
Big in size.
Weak?
Size big.
Big size, okay. Any other point? Small change? थोड़ा ठीक से बोलो ना. I can speak that loudly. Why can't you? Speak loudly. Resolution. What do you mean by resolution?
Small changes it is not able to detect correctly.
Okay. Any other point? I want to know what is the main disadvantage, and that is why those thermocouples are not used these days. There are far better thermocouples available. But unfortunately, when he carried out this experiment, this type of thermocouple was only available in the market, so he did his experiment. The biggest disadvantage of those thermocouples is rather that it has a very non-linear output. The output which is available at the thermocouple is very non-linear in nature. Although with digital thermocouples also the output is non-linear in nature, but that was very, very high. The degree of non-linearity was very high. So to make it linear, you need some compensation, you need some circuitry, etc., etc. Otherwise, it is difficult to solve your problem. Anyway, now thermocouple output is also very, very small. Thermocouple output is also very, very small. So what did he do those days? He made a group of thermocouples by connecting so many thermocouples to increase its output, and that he named as thermopile. It is known as thermopile. So उसने thermopile बनाया बहुत सारे J-type thermocouples को लेके. He grouped them in series, parallel connections, group connections, and he made a thermopile. So output was more, but non-linearity problem was there. But he had to bear that. Now he needed temperature sensors. The temperature sensors those days he used, because the temperature is very high, higher side, So he had to use nothing but RTDs. Speed of rotation of the motor shaft. You see, what is happening, the car is moving linearly, but what is happening to his rotor, which is transmitting the power, वो कहाँ कैसे चलता है? It is rotatory in nature. So the rotatory shaft का जो speed है, that will be in RPM. That will not be in kilometers per hour, something like that. It's not the velocity. It is the speed, rotatory speed or angular speed, you can say. So a tachometer was used for that. And vehicle speed velocity meters are available. Those days also Maruti car had the velocity meter and he used that. So simple circuitry was made with the help of these gadgets. He did a circuitry, he fabricated a circuitry and he put it in the car. And what did he do? He was changing the velocity of the car and he started from very low speed, say 30 kilometers per hour, then 10 kilometers का addition कर रहा था. So 30, 40, 50, 60, 70, 80, 90, 100, 110 and so on. Now tell me one thing, you all are driving cars. Is it good that you drive your car at a very high speed? People have a thinking that you save fuel, because ultimately the objective is saving fuel. That was his objective also. One is saving fuel, another is the fuel burned had lot of heat, so convert it back into electricity and make it a useful usage. That was the two objectives. तो क्या अगर आप 110 की स्पीड में चलाएं गाड़ी या 150 की स्पीड में चलाएं तो आप फ्यूल सेव करते हैं? नो. व्हाई नॉट?
के लिए सर एक्सीलेटर को ज्यादा प्रेस करना पड़ेगा तो वो फ्यूल का जो इंजेक्शन होगा वो उसको ज्यादा जाएगा. और एक उसका नॉर्मल रेंज होता है जैसे 45 to 60. उस रेंज में अगर चलाएंगे तो सही तरीके से.
Exactly. So every car has an optimum speed. It is a range, as he says, 50 to 65, 68, something like that. This is the most optimum range of driving a vehicle. If you drive the vehicle, of course, in a national highway, you drive it at a higher speed. But normally, if you drive it all the time in city areas also, you don't achieve average. And what are you achieving actually? In turn, क्या हो रहा आपका? It is the wear and tear of your engine, wear and tear of your car. Actually, it is life is being decreasing. ठीक है? So life को आप decrease कर रहे हैं. You are not achieving any average better. You are not saving any fuel, and there is a chance of accident. ऊपर चले जाएंगे. So why do you drive the car at a higher speed, which does not mean anything? You see, you will reach say 15 minutes before, 10 minutes before, depending on the distance. And in city areas, hardly 2, 3 minutes, 5 minutes, 10 minutes का difference है. Heaven is not falling on you. Is the heaven falling on you? Why are you trying to dash to the hell? Heaven is not falling on you, or you are trying to dash to the hell for no reason, for no achievement, for no objective, for no aim. So don't try to do this. This is a foolish idea कि मैं इतने ज़्यादा में चलाऊंगा स्पीड से तो मैं जल्दी पहुंच जाऊंगा और दूसरी चीज है मेरा एवरेज भी बेटर हो जाएगा. नो, यू आर नॉट अचीविंग एनी एवरेज. यू आर डूइंग harm to your vehicle, and you are also polluting the atmosphere. Higher this thing acceleration, more is the pollution. ठीक है? As somebody was saying that the petrol contains lead, and the lead is very very dangerous for human life. The lead जो होता है इसके solid precipitation की तरह ये air में जाता है. It does not give you the fume. ये फ्यूम नहीं क्रिएट करता है. इट क्रिएट्स सॉलिड्स पार्टिकल्स. वो पार्टिकल्स अगर आपके लंग्स में जाएगा तो इट इज वेरी वेरी डिफिकल्ट. इट्स वेरी वेरी हार्मफुल. दैट्स व्हाई यू शुड अवॉइड दिस. तो व्हीकल स्पीड का भी एक एवरेज स्पीड होता है, एक ऑप्टिमम स्पीड ऑफ रेंज ऑफ स्पीड होता है जिसमें आप चलाने से आपकी गाड़ी की लाइफ बनी रहेगी, आपका हेल्थ ठीक रहेगा, आपको टेंशन कम होगा, एक्सीडेंट्स की चांस कम होंगे और एटमॉस्फेयर भी क्लीन रहेगा. So what he did, ये सर्किटरी बनाया, मोटर स्पीड को एक मिनिमम स्पीड से लेके एक हाई स्पीड तक उसने क्लासिफाई किया, 10 किलोमीटर पर आवर से बढ़ाते गए एंड कुछ रीडिंग्स दिया. नाउ टेल मी व्हाट कुड बी द रीडिंग्स. क्या क्या रीडिंग्स लिए हैं, मैंने सर्किटरी आपको बताया. एक तो इट इज डेफिनेट दैट यू वांट टू नो द टेम्परेचर, व्हाट इज द रेंज ऑफ टेम्परेचर, व्हाट इज द चेंज इन टेम्परेचर एंड विद द वेलोसिटी. जैसे वेलोसिटी चेंज कर रहे हैं तो टेम्परेचर कैसा बढ़ रहा है. Another thing is the speed of the vehicle. Another thing is the rotation in RPM. Another thing is the heat, total heat generated. And then what is the conversion, means electrical power. और इसके अलावा ल्यूब ऑयल का टेम्परेचर वगैरह आप नोट करेंगे. So these were the readings. That was a very simple experiment Dr. Khatri conducted, and the readings or the observations what he got, they are very very meaningful. Luckily I have got them, but it is a very age old experiment. So earlier days में लोग इसको share नहीं करते थे, but nowadays it can be shared. This is a very old experimentation. Let's see. This is the case study of 800cc Maruti car. The total electrical energy required is worked out to be 430 watts. अगर 800 सीसी की कार है तो उसमें 430 वॉट जो है इलेक्ट्रिकल पावर की आवश्यकता होती है. यू नीड अबाउट 430 वॉट्स. हाउ? इट इज रिटन हियर. यू हैव हेडलाइट, यू हैव टर्न सिग्नल लाइट, टेल स्टॉप लाइट, साइड टर्न लाइट, नंबर प्लेट लाइट, बैक लाइट, इंटीरियर लाइट, मीटर पायलट, इग्निशन सिस्टम, cooling fan, horn, radio and tape recorder, etc. These are the main accessories of an 800cc car. Of course, with the latest cars available, there could be much more. There are much more gadgets are there. Computer is there. It is a computerized car also. These days, the cars are computerized. With Honda City and all those things, you have much more electricity requirement. But those days, 800cc was one of the pioneers. It was one of the best cars, and this is the condition what you have. So we have written the quantity, we have written the power required for one single, and the total power required is this much. So if you work it out, the maximum load of electrical power is 430 watts. It comes out to be 430 watts. Average load during the day is about 100. It is about 100, इसमें देखिए 180 watts, and average load during night is 300 watts. Why? Why is it so? Headlights will be on only during nights. Similarly, many lights will be on during the night only. You may not require them in the daytime. Okay. So daytime का जो average load है, that works out to be 180 watts, and during the load night time it works out to be 300 watts. But the total load maximum 430 watts. Say it is 400 watts. So what does it tell you? ये तो आपके सामने ही है, आप अपने कार का भी निकाल सकते हैं, अपने टू व्हीलर का भी निकाल सकते हैं. What does it indicate you? क्या बोलता है ये जो specifications है? When it is before you, then what does it mean? क्या समझाता है ये आपको? What does it indicate? Tell me.
इनकम्बशन से हम लोग 40 वोल्ट सिर्फ एनर्जी जनरेट कर रहे हैं अपनी इलेक्ट्रिसिटी जनरेट करने के लिए कार के लिए.
This means it is very clear that 430 watts, if you have somewhere electrical power, you can run the car, you can meet its requirement. Simple as that. तो वो 430 watts कहाँ से जनरेट हो रहा है right now? कहाँ से मिल रहा है आपको? Battery and fuel. You are burning the fuel and you are charging the battery and storing it and using it. Is it not?
Yes, sir.
Now, if I burn the fuel, look at the efficiency which I give you. And only 35% say 40% best possible is get converted into electrical power. and rest are being wasted, I would say wasted or misused to form nothing but heat, which is causing first of all गर्म कर देता है, इंजन को गर्म करता है, आपको गर्म करता है, इंजन खराब भी हो सकता है. Many times it is due to high temperature your car gets खराब हो गया, उसका गास्केट गल गया, उसका पंप खराब हो गया. This happened with my son's car only few I think 1 month back when he was driving it from Delhi to Gurgaon. It happened because of what? Because of heat generated, and that heat is harming you, not doing any favor to you. Hardly it is converting electrical energy, and that was the point which struck. Why not reutilize that heat, recycle that heat, and get it converted into electrical power, and I can meet that from this for this function. So this was the experimental details or the observations which he received from his experiment. You see, I said he started with a vehicle speed of say 30 km per hour, and 10 kilometers he has increased, and he has not gone beyond 100. मारुति 800 सीसी में 100 से ज्यादा ऊपर चलाने का कोई तुक नहीं बनता है. There is no use. गाड़ी तो इतनी पतली सी छोटी सी गाड़ी, उसमें 110 में चला रहे हैं, and you get this that and you dash and what not. There is no point. So 100 भी बहुत ज्यादा है, but for the experimental purpose he went up to 100, and the engine speed in RPM was found to be 1240, 1650, 2010, 2470, 2880, 3290, 3700, 4110, etc. The exhaust gas temperature was 824, 862, 908, 950. देखिए कितना ज्यादा टेम्परेचर है. 1000 डिग्री के पास टेम्परेचर है, उसको छुएंगे तो बुरा हाल हो जाएगा. एंड इसके लिए उन्होंने के में नोट किया था, हमने डिग्री सेल्सियस बताया, बट ही यूज्ड इन केल्विन. So these are the temperature ranges. Fantastic, high range, right? Then water temperature, जो water आपने radiator के लिए यूज किया, उसमें कितना राइज है? 79, 79, 80, 80, 81, 82, 84, 86 डिग्री तक राइज कर गया. मैंने बॉयल करने लगा करीब करीब पानी. Imagine, have you seen your radiator sometimes? पानी कितना गर्म होता है. I had specifically saw that when this car was stopped at the Gurgaon, तो वो जो पहले जब ब्रिज है वहां जाके रुक गई गाड़ी, बंद हो गई. तो हमने उसको साइड लगाया. Then we were trying for a टेक्नीशियन, उसको ढूंढ के लाए, और वो उसको बोला कि गाड़ी बहुत गर्म हो गई है. उसने उसके अंदर पानी डाला, घू करके पूरा निकला. That was the affair, and those days he did it. अभी भी वही कोई नहीं करता, वही चल रहा है सिस्टम. Now the lube oil also temperature, you look at this lube oil, 88 डिग्री सेल्सियस तक lube oil का टेम्परेचर आ गया. और कहीं आपका lube oil खत्म हो गया तो आपकी कार तो बोल जाएगी. It will go for his head. So 80 डिग्री से चालू के 88 डिग्री तक चला गया when you are driving at 100 kilometers per hour. The full compressor was 48. The consumption actually, compression means consumption. 48 से चालू होकर 70 तक चला गया. Imagine 48 cc was the consumption, or in form of compression you can say, and it went up to 70 when you drove at 100 km. Is it not foolishness? This tells you, this gives you a right kind of direction that please don't do it. इसको मत करिए आप, क्योंकि किसी ने आपने कभी भी एक्सपेरिमेंट तो किया नहीं होगा. हाँ, कभी आपके स्कूटर से पैर में फफोला पड़ गया, अरे बाप रे बहुत गर्म था. That you have imagined, but you don't know what was the temperature there, and you never thought for the remedy. You never thought कि what should I do? You are all engineers. इसमें ऑटोमोबाइल इंजीनियर होने की कोई बात नहीं है. It is the energy what is more concerned. You should feel concerned about that. Can I use that energy for some good purpose? एक ही पैर में छाला पड़ाने के लिए हमने वो यूज कर लिया. It's a very bad application. You are wasting energy for nothing, and you are harming actually yourself and the atmosphere. So the heat supplied in kilojoules per hour 9.41 से चालू किया and 76.01 में टर्मिनेट हुआ. Hell of a lot of change. अगर आप 30 किलोमीटर पे चलाएंगे तो heat supplied is very less, no doubt. But if you drive it at 100, you look at the heat supplied. 76.01. ये इंक्रीज होता जा रहा है, बहुत ज्यादा इंक्रीज हो रहा है ये. देर ल्यूक टेम्परेचर में ज्यादा इंक्रीज नहीं हुआ, वाटर टेम्परेचर में भी 86 तक गया, बट हियर इट इज a drastic change, a drastic change. And then the heat available at the exhaust. ये हीट सप्लाई इतना है, लेकिन हीट एग्जॉस्ट में उससे भी ज्यादा अवेलेबल था. एंड इट स्टार्टेड फ्रॉम 46.58 to 222.26. Imagine the amount of heat present in the exhaust of that flue gas, because that fluid is so hot that you are getting 222.26 kilojoule per hour. इतना ज्यादा आपको प्रोड्यूस कर रहा है. एंड व्हाट आर यू डूइंग विद इट? बहुत गर्मी हो रही है, खिड़की खोलो, एसी चलाओ, उल्टा काम कर रहे हैं. Now you are not energy aware person. I am telling you, not only you, it is me, it is everybody. Very few people are energy concerned. अगर आप एनर्जी कंसर्न हो जाएंगे तो इस कंट्री की हालत बिल्कुल दूसरे किस्म की हो जाएगी. इसका कॉम्प्लेक्शन बिल्कुल चेंज हो जाएगा. Try to be energy concerned. Try to be energy oriented person. Try to be energy efficient person. And try to understand, why should I use energy for a good cause? Energy is one thing which is given to you by the God in form of many, but that should be utilized meaningfully. ये इसका ऑब्जेक्टिव है इस पूरे केस स्टडी का. Now let us see. He performed these. What did he do with these readings? पहले तो ये readings ले लिया, उसके बाद क्या किया? He was there. A curve was, he drew two curves from 30 to 1200 he went. ये speed आया था 30 से लेके 100 तक. And the average energy which was available in watts, he noted it into electrical watts with the help of wattmeter, and it was available up to 1200. देखिए 30 से 1200 भी जा रहा है, और 30 से जो जा रहा है वो 430 something जा रहा है. Minimum available was about 500 watts. The minimum electrical energy which he could get from his circuitry, which was available at the output, was about 400 and about 500 watts. But अगर आपने efficient circuitry लगाया होता, he did lot of modifications he did in his circuitry, in his measurement, in his techniques, in his conversion technique, and he could get up to 1200. What was the requirement? 400, 430. Average was 300, 180. But so much is available, and that is untapped. I was giving you the example of small hydropower that day. I was talking to you, isn't it? And small hydropower, I said, it is 25,000 megawatts is the potential, and we have tapped only 500 megawatts. Very sad story. Why can't you tap it? Now, lot of research is taking place in this area, wherein small hydro is getting lot of preference. And people are working in states like Himachal, Uttarakhand, J&K, Arunachal Pradesh, etc., etc., wherein you may have the potential. What potential should have? Potential किस चीज से बनता है? वाटर हाइड्रो का जो कन्वर्शन है, it is the height, it is the terrain, geographical terrain. If you have the height, then you may have the water head. If you have the water head, you will generate. प्लेन में वाटर हेड आपको नहीं मिलता, इसलिए प्लेन्स में स्मॉल हाइड्रो या हाइड्रो का प्रोजेक्ट लाना मीनिंगफुल नहीं है. बट इन टेरेन्स लाइक हिली प्लेसेस you should go for such thing, and the potential must be tapped. Why I am telling you this point here is that lot of potential is available, but it was going untapped. That was the objective. That was the research. It is a very small research, but it is very meaningful research. आप भी ऐसे टाइप की प्रोजेक्ट्स कर सकते हैं, and I am telling you that you all are teachers. You have lot of student force with you. Why don't you give this kind of project to them? लैब में ये काम कीजिए, energy oriented projects, and of course application of technology. We talk of this street lighting, is it not? Street lighting में क्या होता है? पोल, सारे पोल्स जल रहे हैं, रात के 2 बजे भी चंडीगढ़ में सारे पोल्स जल रहे हैं. लाइट, so much of light is available. Is it required? Then what will you do? मैंने आपको पहले ही बताया था. What will you do? You can schedule the poles कि after so much of time, say 11 o'clock in the night, when vehicles are very less, traffic is very less, you reduce the number of poles which are on. And also you schedule it. एक ही पोल को ऑन कर दिया, 2 को ऑफ रखा, वो एक ही ऑन है, वो भी गलत है. उससे उसकी लाइफ खराब होगी. What will you do? After some time, you switch it off and put on another lamp pole. So इस तरीके की स्विचिंग करने से इसको बोलते हैं शेड्यूलिंग. Switching, scheduling. If you do it, the life of the device is also increased, the power consumption is also less, and at the same time, the flue gases are reduced, the atmosphere pollution is improved, reduced. Ecological balance you will achieve. Another thing, this is one way, right? इसको बोलते हैं energy efficient technology. Now another energy efficient technology is कि जो स्ट्रीट लाइट्स होते हैं, ये जब अंधेरा होता है तब जलना चाहिए, एज सिंपल एज दैट. और जब लाइट आ जाएगी डे लाइट, तो इसको क्या करना था, इसको ऑफ कर देना चाहिए. ऐसा होता है क्या? मेनी टाइम्स 12 o'clock in the day also you find that so many street lights are on. और कई बारी अंधेरे में भी नहीं जलता है. दोनों एक्सट्रीम आर पॉसिबल, both the extremes, that it is dead dark but no street light is on. Either it is defective or it is not being put on by someone. दो ही कंडीशन हो सकता है. Either it is defective, it does not get on, or somebody has not bothered to put it on. Similarly, if it is daylight, if it is on, then somebody has forgotten to put it off. Now, what technology you can do here?
Using LDR.
Surely you can devise a circuit wherein LDR can be used, which will sense the light, daylight, and accordingly it will put off certain poles. It will again put on certain poles. We have turn on circuit, we have turn off circuit, turn on at dark, turn off at light, illumination circuits, controllers. This is a very simple circuit, but the technology is very meaningful. You have to use these appropriate technologies to save energy, to save environment, to save people, and to save the human being at large. Is it not? So that kind of things, I think you can also give your students as projects, minor projects, then major projects, controllers, instruments, instrument and scheme, and your protection schemes, etc., related to the sector of energy. Is it not correct? So, from the curve, what can be observed? From this curve, many things is observed. It can be observed that energy utilization can go up to 1200 watts. Now, mind it, again and again I am telling you, this is an experiment carried out those days, about कुछ नहीं तो कम आज से 30 साल पहले की बात, 30 years. And nowadays the devices are so much improved in their functioning, in their efficiency, in their effectiveness, that you can get even far better results than this. So that is the limit. That is the kind of the sky is the limit. You have to have the attitude only to work in these sectors, in these fields, and maximum. I think we have to read that, maximum than what is utilized presently. मतलब जितना अभी इस समय एनर्जी यूज हो रहा है उससे कहीं ज्यादा एनर्जी उसके पास अवेलेबल है, which goes untapped. This is the point I'm again mentioning, that in small hydro case also it was untapped. Here also it is untapped. In many of the cases the energy is there but it is untapped. So when it is untapped, it is not doing any meaningful work, and I can call it a wastage. There is no loss, but there is a wastage, and wastage is also indirectly a loss. So if efficiency goes down, effectiveness goes down. Correct? So what are the conclusions of this small experiment? Do you like this kind of project or not? ये टाइप की प्रोजेक्ट आपको लेना चाहिए. And the case study indicates you that you should be an energy oriented person, an energy aware person. that it gives you the indications. From experimental data, it is observed that enough heat energy is available in the exhaust. Where is the point where you have to tap? That is the exhaust. सबसे गर्म आपका exhaust होता है. Now many of you are electrical engineers. Can you tell me transformer में सबसे ज़्यादा temperature कहाँ होता है? Highest temperature. Where? Yes, come on. Windings. So you should know. इसी को कहते हैं energy conservation opportunity. What is the energy conservation opportunity here? It is the exhaust. It is the radiator. Right? क्योंकि वहां सबसे ज्यादा हीट जनरेट हो रहा है और वहीं से फ्लू गैस आपकी पास हो रही है. So that becomes your ECO, energy conservation opportunity. In case of a transformer, the highest temperature part of the transformer is the winding. सबसे ज्यादा हीट वहां जनरेट होता है. And nowadays उसको कूल करने के लिए एंड एफिशिएंसी को बढ़ाने के लिए क्या करते हैं हम? कूलेंट डालते हैं, कूलिंग करते हैं ना. तो कूलिंग, ऑयल कूल्ड ट्रांसफॉर्मर्स आर देयर, ऑयल कूल्ड. तो पूरा ट्रांसफॉर्मर का जो कोर समेत जो वाइंडिंग है, दैट इज ड्रेंच्ड इन ट्रांसफॉर्मर ऑयल. And the oil has got two main purpose. One is cooling, another is insulation. But have you heard of the transformer which are now being used as? No, air cooling तो उसमें ही था. जब वो कूलिंग पूरा नहीं हो पा रहा था तो बाहर से पंखे वगैरह लगा दिया, एग्जॉस्ट लगा दिया to improve the cooling system. What is the latest? Dry transformers. Dry transformers are the transformers which don't have any cooling agent. Dry कहलाता है. तो अब बताइए कि what is this? This is because you don't want to misuse that energy in the form of heat. उसको जाने नहीं देना चाहिए, उसको रीयूज कर लो. आजकल it has become mandatory whenever you go for higher capacity connections, इसकी maximum demand ज्यादा होगी, you are going for ड्राई ट्रांसफॉर्मर्स. मैंडेटरी हो गया. हमारे यहां पर ड्राई ट्रांसफॉर्मर लग गया. यू कैन सी इट लाइक दैट. पीपल आर चेंजिंग. इट इज अ चेंज ऑफ टेक्नोलॉजी which guides you and it is always related with the energy. Everything is energy related. कोई भी चीज आप कहिए, मैंने आपको बोला था जब आप खाना खाते हैं तो उसके बाद आपको सुस्ती क्यों आती? You know, you waste, actually you consume some energy is consumed. You have to dissipate it to eat the food. इसलिए आपको सुस्ती आती है. इसलिए जो ड्राइवर्स होते हैं ना, वो मेनी टाइम्स खाते नहीं है. सो सुस्ती आ जाएगी तो क्या होगा? What will happen? So they avoid. वो कहते नहीं हमें खाना नहीं. वो क्या करता है? चाय पीता है. उल्टा करता है. टी कड़क चाय पी लेता है. जो ट्रक ड्राइवर्स होते हैं ना, इनका एक होता है कड़क चाय. इतने किलोमीटर वाली चाय मार दे, 200 किलोमीटर की. मतलब हमें 200 किलोमीटर चलना है, उस हिसाब से चाय बना दो. मंजा लगा देते हैं, वहीं पर आराम करते हैं, है ना. ढाबे में खाना खाते हैं, थोड़ा चाय बहुत पीते हैं, कड़क चाय बोलते हैं. हैव यू हर्ड ऑफ इट?
मलाई मार के बोलते हैं.
मलाई मार के वो लोग नहीं, वो तो कड़क चाय ज्यादा बोलते हैं. मलाई मार के तो सो जाएगा. यस. सो इसलिए कहने का मतलब है कि एवरीथिंग इज एनर्जी ओरिएंटेड, एवरीथिंग एनर्जी रिलेटेड. दैट इज व्हाट आई वांट टू टेल यू. यू पीपल आर ऑल matured people. You know what is the significance of energy, but giving you such examples will definitely orient you for the energy sector, right? So enough heat energy is available in the exhaust. This was the first point. If this heat energy is converted into electrical energy, it can fulfill the requirement of the car. देखिए, कार में जितनी भी रिक्वायरमेंट थी वो सिर्फ कन्वर्शन से ही हो सकता था. अब बैटरी की आवश्यकता ही नहीं होती है. There is no use of battery. You know, olden days you used to have the bicycles. उसमें एक डायनामो फिट होता था. That used to give you illumination. कहाँ से आ रहा है? कोई बैटरी तो है नहीं उसमें. So rotation से you are converting your rotational energy, that is kind of mechanical energy, into electrical energy. Now that concept is there. It's a very old concept of converting some energy into इलेक्ट्रिकल एनर्जी. व्हाई इलेक्ट्रिकल एनर्जी? क्यों इलेक्ट्रिकल एनर्जी में कन्वर्ट करना चाह रहे हैं? I told you in the very beginning class that the electrical energy is the most utilized form of energy. It can be transmitted from one place to another very easily. It can be generated in many ways, and it is the cleanest form of energy. बार बार आपको ये कह रहा हूँ कि आपने मन में डालिए इस चीज को. You write it with golden letters in your diary that without electrical energy nothing is possible. Nothing is possible. You are totally dependent on electrical energy. That's why conversion of any form of energy which is available into electrical energy. That is the important point I wanted to make through this course. Is it clear to you now? So, if this it can fulfill the requirement of the car. Here it was the requirement of this particular car. In many cases, you may be required electrical energy for different purposes. So if you can, जैसा कहते हैं ना, मछली को फ्राई करना उसी के तेल से. Have you heard this? फिश को फ्राई कर लो उसी के तेल से. Don't use any external oil. उसी का जो तेल निकलेगा उसी में फ्राई होगा. This is intelligent. This is intelligence. You can do it. So here also you are using the energy which was untapped before. Nobody knew. और पैर में छाला पड़ा गया, हाथ में छाला अड़ गया. उसको हमने क्या किया? कन्वर्ट कर लिया इलेक्ट्रिकल एनर्जी. That is the best possible thing. The heat energy carried out by the exhaust depends on, this is experimental observation, load and speed of the engine. Now what do you mean by this? You have seen that particular list, that table. As you increase the speed, the heat energy is also increasing. As you load the engine, the heat energy is also increased. So it is the kind of misuse of your input that is in the fossil for creating something which is not used. तो उसको useful बना लीजिए by converting into a useful form of energy which is nothing but electrical energy. Higher speed load is more, for more heat energy is generated. Higher speed and load, more energy is generated. This was also a conclusion of this experiment. It is also observed that maximum electrical requirement for 800cc car is 430 watts, out of which average load during daytime is 180 watt. This is a repetition. Average load during night time is 300 watt. This is also conclusion. It is specifications. Now nobody is using 800cc Maruti car. Everybody is using big cars, at least the medium sized cars. Can anybody tell me what is the electrical requirement of your car? You all may be using, or at least two-wheeler तो है ही है, लेकिन किसी ने इसको सोचा ही नहीं कभी. So I think I have initiated you, I have sparked your mind to work in these lines so that you know about your vehicle which you are driving all the time. उसके बारे में जानो तो सही. How many of you can change the this thing, wheel, if it gets out? Can you change it? You can change it. Only one out of how many? 20-25 people. This is a sad affair. अगर मान लीजिए आप कार चला रही हैं, आपको बोल रहा हूं, what is your name? गगनदीप. गगनदीप थोड़ी खड़ी हो जाओ. You are driving a car और किसी जंगल के पास से आप जा रहे हैं, आपका चक्का खुल गया, आप क्या करेंगे? What will you do? मैनली काम ऐसे आप नहीं करेंगे. ये जो फिर आप गाड़ी क्यों चला रही हैं? Don't drive. So what I want to say, don't take it lightly. ये तो बहुत पतला आदमी है, कहाँ मैनली है? खड़े हो जाइए आप. ये कहाँ मैनली लगता है? But you can do it. Imagine this fellow, he is not a manly person, but he can do it. So perhaps you need the attitude and skill, not the muscles. Okay, I can also do it. I am not also very manly, right? So bad job. So it is the skill, it is the attitude which is more important than looking giant and all. Giant को कुछ नहीं करता. वो बताता था, वो क्या बोलते हैं, अलादीन का चिराग होता था ना, उसमें giant होता, उसको पता ही नहीं है क्या करना है. He doesn't know what to do. Aladdin calls him और वो कहता है, बताओ मेरे आका मुझे क्या करना है. So better be Aladdin, not that giant. Okay. तो वो क्या है, वो आपका गुलाम है, यू आर द मास्टर, राइट. सो एटीट्यूड होना चाहिए, काम करने की इच्छा होनी चाहिए, एंड स्किल होनी चाहिए. स्किल के बिना कुछ नहीं. दिस इज चेंजिंग द व्हील इज अ स्किल. ठीक है. सो यू कैन डू इट. More than sufficient heat energy is available in the exhaust and can be utilized not only to meet the electrical requirements of the car but for charging the battery and as also for ignition. Ignition के लिए क्या चाहिए होता है, बता सकते हैं कोई?
इलेक्ट्रिक स्पार्क होता है.
इलेक्ट्रिक स्पार्क, व्हाट डज इट मीन? इलेक्ट्रिक स्पार्क, बिल्कुल करेक्ट चीज आपने बताया, बट व्हाट डज इट डू? दैट स्पार्क क्या करता है?
स्पार्क होने के बाद वो जो फ्यूल होता है उसमें ये होता है, बर्न करता है वो.
नहीं, वो सब ठीक है. वो जो स्पार्क करता है उसका मतलब क्या है? स्पार्क इज ए हेवी करंट.
नेगेटिव एंड पॉजिटिव को थोड़ा
शॉर्ट करने से क्या होता है? हेवी करंट फ्लो करता है. हेवी इलेक्ट्रिक करंट इज फ्लोइंग, दैट इज नथिंग बट कॉजिंग लॉट ऑफ इलेक्ट्रिकल एनर्जी. So that can also be achieved with the help of this. Sparkless motors आ सकते हैं. These are the findings, very important findings what he did, and he did lot of things in the car which was meant for the experimentation, not in the use for the one which he used. उसको use किया उसमें, और उसने बहुत सारी चीजें बताई. Later on he became a very high post holder in Maruti, not only in Maruti, some other automobile companies also. आजकल तो वो world wide घूमता है. अभी आया था कुछ दिन पहले. He is a very well known figure in the field of automobiles. So these are the findings. Okay, so you can use it for ignition, you can use it for heating your car, especially in winters. Winters में देखा खर्रर्रर्र ऐसा होता है ना, आवाज. चलती नहीं गाड़ी. क्यों नहीं चलती? It needs heat. That can be done with the help of this. Heat energy can be used for heating the vehicle in cold conditions. These are some of the conclusions which we got from that particular test and from that particular experiment, and these are very useful. Some of them are also there. Energy consumption can be further reduced if air cooling is done to maintain the temperature of the engine. अगर आपने air cooling करना है तो air cooling के लिए आपको exactly एक exhaust fan या fan की आवश्यकता होगी. उसकी भी energy इसी से use कर लीजिए और heat को कम कीजिए. By using air cooling, the energy required for water cooling, that is about 300 watts, can be straight away avoided. Also reduces the fuel consumption. This was the ultimate thing. Fuel consumption भी कम होगा. Ignition improve हो गया, हैं? Heating हो गई आपकी कार की. It became comfortable. वो जो starting problem था वो भी नहीं हुआ. All these things were available. These were possible with the help of this experiment. So this is the small kind of case study which I wanted to discuss with you. Now the floor is open for queries. Any queries you have, I would like to know them and try to answer them from my capacity. Let us go to the center by center, and then finally we'll come to you also. Yes, please. We'll first go to Dr. Virendra Swarup Group of Institute, Unnao. Dr. Virendra Swarup Group of Institute, Unnao, please. Have you got any queries, any questions, please?
Good afternoon, sir.
Good afternoon, very good afternoon.
Sir, the question is, you have talked about the dry transformer.
Yes, yes.
So we just want to know the concept, how the cooling is done in dry transformer.
Yeah, dry transformers have a kind of gel they use, and that forms the heating, the cooling atmosphere it creates. The heat is not generated and the heat is not sustained in the system in the transformer. That's why it cools the transformer. It always maintains a particular temperature, and that is known as dry transformer.
So what is the coolant there? It is some gel you said, I think.
Yeah, it is a gel, and also some air cooling is there.
Okay. Okay. Thank you, sir.
Thank you.
No, thank you, sir.
Any other questions? Any other questions from Dr. Virendra Swarup Group of Institute? Okay,
No.
yes. Yes, please.
No, sir. Thank you. No queries.
No questions. Okay. Now we go to the second college, second center, that is RD Engineering College, Ghaziabad. RD Engineering College, Ghaziabad. Yes.
Good afternoon, sir.
Good afternoon.
There is no query from our end, but we have a request that it would be good if you can share the timetable in advance with us. Timetable of the course.
Okay, okay, that will take care. Thank you. Thank you for your
Thank
suggestion. Aligarh College of Engineering and Technology, Aligarh. This is the third center. Aligarh College of Engineering and Technology, Aligarh. अच्छा. Fourth center is Aryabhatta College of Engineering and Technology, Bagpat. Aryabhatta. Aryabhatta College of Engineering, Bagpat. Hello? Yes, please. Hello?
No question.
No questions. Okay, thank you very much. Jaipur Engineering College. Jaipur Engineering College. जयपुर इंजीनियरिंग कॉलेज प्लीज. वहाँ नहीं है. ओके. विवेकानंद इंस्टीट्यूट ऑफ इंजीनियरिंग एंड टेक्नोलॉजी, गाजियाबाद. विवेकानंद इंस्टीट्यूट ऑफ इंजीनियरिंग एंड टेक्नोलॉजी, गाजियाबाद. Nobody is there? One person. Yes, please. Do you have any queries?
No.
Yes. Please speak out. बताइए. He doesn't have any queries, please. Then Krishna Engineering College, Ghaziabad. Not correct. Okay, at this point of time, I would like to tell you all that we are coming here sharp at 2 o'clock. Sharp at 2 o'clock for the valedictory program. And please mind it that our director is going to join it. और जितने भी सेंटर्स हैं उससे मेरी ये दरख्वास्त है, दिस इज माय रिक्वेस्ट टू ऑल ऑफ देम, कि 2 बजे आप शार्प यहाँ पर आ जाइए और डायरेक्टर जो आपसे क्वेरीज करेंगे या आपसे फीडबैक लेना चाहेंगे उनको आप थोड़ा बताइएगा. दिस इज माय रिक्वेस्ट टू ऑल द सेंटर्स कनेक्टेड. ओके, आप लोग प्लीज डोंट डिस्कनेक्ट. आप लोग जो कनेक्टेड हैं आप डिस्कनेक्ट ना करें और 1 घंटे बाद 2 बजे आप लोग यहाँ आ जाइए. मैं डायरेक्टर को बुलाऊंगा एंड ही विल लाइक टू इंटरैक्ट विद यू taking your feedback, please. So give a good show. This is my request, artist request to all of you. Is it okay? So we are coming here sharp at 2 o'clock. Now I come to these participants from the studio, local studio. Thank you very much. Please don't disconnect. आप disconnect मत कीजिए. 2 बजे यहाँ पर हाजिर हो जाइए. Thank you so much. So many things which are automobile details.
तो इलेक्ट्रिकल एनर्जी में सर किस तरह से कन्वर्ट किया गया?
वो सर्किटरी अभी क्या सर्किटरी यूज कर रहे हैं वो मैं नहीं बता सकता, बट देन दिस वाज द ओरिजिनल. ये ओरिजिनल है इसलिए मैंने आपको बताया. नाउ यू कैन इन्वेंट योर ओन सर्किट. व्हाई आर यू वरीड अबाउट मारुति?
तो सर जैसे उसमें उसका टेक्निक क्या होगा, से वो जो हीट हाफ हो रहा है उससे वाटर को गर्म करेंगे, वेपर बनाएंगे, या फिर और कोई टेक्निक है?
नहीं, वाटर गर्म नहीं करेंगे, उसको इलेक्ट्रिसिटी डायरेक्ट कन्वर्ट कर लेंगे और उस इलेक्ट्रिसिटी को इन पॉइंट्स में दे देंगे. ये है. और बैटरी को भी चार्ज उसी से करेंगे, इग्निशन भी उसी से करेंगे. दिस वाज द टेक्नोलॉजी. वेल यस, सो मच ऑफ इट हैज बीन इम्प्लीमेंटेड, बट अभी तो इससे भी ज्यादा मॉडर्नाइज हो गया. बहुत सारी चीजें मॉडर्नाइज हो गए, कंप्यूटराइज हो गया. द होल सिस्टम इज कंप्यूटराइज नाउ. यस, एनी अदर क्वेश्चंस? एक मिनट. हेलो. that can be converted into electrical signal. It is a change of signal that can be done. ये हो सकता है. Hello.
respected Dr. M.P. Punia, Director NITI Chandigarh, Dr. S. Chatterjee, Professor and Head Electrical Engineering Department, faculty, staff, and my dear students. A very good afternoon to one and all. We have come to the end of this program on STZ on Energy Efficient Management through ICT. Though it is the end of this program, I feel it's just the beginning of our journey towards sustainable development. And instead of resisting our transition, being Indians, we must lead it. So now it is time for us to hear the constructive feedback from all the nodal centers and even our participants here. So first we will start with Dr. Virendra Swarup Group of Institutes, Unnao. Yes, we can hear. Can we hear your feedback?
Yes, ma'am. Hello. Am I audible?
Yes, we are. It's audible. You can just speak.
Okay. Ma'am, on behalf of Dr. Virendra Swarup Group of Institutions, I would like to congratulate Dr. Punia, Director NITI Chandigarh, Dr. Sachan sir, HOD EC Department, Dr. Chatterjee, HOD Electrical Department, me ma'am, Anu ma'am, and Hansraj sir for conducting such a nice session which has enlightened us with the knowledge about energy auditing and renewable and non-renewable sources. We would definitely teach, will be able to teach our students to become energy aware persons. Thank you for the session.
Is there any feedback from some other participants? Can we hear from the participants?
Okay, participants. Hello, ma'am, please. Yes, ma'am, we have got the participant to give the feedback.
Hello.
Yes.
Hello. The session was very useful as it has given the clear concepts about energy auditing, renewable and non-renewable sources of energy, and different cases studied, discussed, made our concept very clear. Thank you very much, ma'am.
Do you feel any changes we have to bring about in the next courses? Is there any feedback like you have? Do you want us to change some sessions or?
Ma'am, we need a session in improvement of power factors, a detailed section for that.
Power factor improvement. Okay, in the next session we will have that.
And we also want these PPTs to be shared.
Okay, PPTs. Anyway, these videos are available in YouTube, so you can go and see that anytime. And we'll see that we'll send the PPTs also. We have your mail ID, we'll send it. We'll send it to the coordinators. Okay, it will also be uploaded. Say shortly, it will be uploaded in all the faculty websites. So in our website itself, in the faculty profile, it will be updated shortly. Okay, so you can take it.
Okay. Thank you, ma'am.
Thank you. And now we hear the feedback from RD Engineering College. RD Engineering College, Ghaziabad.
Good evening, ma'am.
Good evening.
Very good evening to all of you. And first, I would like to thank Dr. Chatterjee and Dr. Punia for successfully organizing this STC. And I would like to thank Dr. Chatterjee, Dr. Sachan, Dr. Lini, Professor Med.
Hello? Hello? Can you hear us? Hello, RD Engineering College. We can't hear your voice. RD Engineering College, please. आपकी माइक स्विच ऑन कर लो. Net का problem. Okay, we will move on to the next college. Aligarh College of Engineering and Technology, Aligarh. They are not connected. Okay, disconnect. ACET Bagpat. Are you there? ACET Bagpat.
Yeah, there.
Hello.
Hello. Is it ACET Bagpat?
Hello. Good afternoon, ma'am.
Hi. Good afternoon.
On the behalf of Aligarh College of Engineering and Technology, Bagpat, I extend a very hearty thankful to all the speakers for placing your important work and sharing with us your findings and opinions on it. I must mention our deep sense of appreciation to Professor S. Chatterjee, Mrs. Sumi, myself, and Dr. Jagdish Kumar areas are of great benefit for the participant as the topic match with the currently working problem. Thank you, ma'am.
Okay, did you face any problems which we have to rectify next time? Did you face any problems?
Hello, pardon, ma'am?
Did you face any problems which we have to rectify next time?
Yeah, ma'am, if the schedule is available in advance, then that is much beneficial for us. Session-wise schedule.
Availability.
What? We couldn't hear.
हिंदी में बोलो.
आप हिंदी में बोलो.
मैम अगर प्रोग्राम का शेड्यूल सेशन वाइज अगर एडवांस मिल जाए दैट विल बी मच हेल्पफुल फॉर अस.
Whose timetable?
Timetable to that.
Most of the lectures, only one lecture because of the expert, he couldn't reach on that time, so we just changed. Baki, all the lectures are according to schedule.
Timetable.
Okay, anyway, we'll see to that. Like it will be updated to you next time. If there is a change in lecture, we'll just update it to you. Thank you, sir. There is any other participant want to share their views? Is there any other participants from RD Bagpat?
No, ma'am.
Okay, thank you, sir. Thank you. Now next, let us hear from Jaipur Engineering College. Jaipur Engineering College is connected?
Yes, ma'am.
Yeah. Can we hear your feedback?
Good for organization, the management, efficient energy management. Audio, video.
Yeah, we can hear you.
Ma'am, your voice not be clear.
Okay, our voice is not clear.
Your voice is.
Yeah, you can hear your feedback. Can you hear us now?
Feedback.
Give your feedback. Give your feedback. We can hear you.
Thank you very much, ma'am. This is your workshop is very good for listen to electrical engineering department.
Audio video. Yes, we can hear you. Please speak out. We can hear. We can hear.
Ma'am, you are audible.
आप बताओ, सुन रहे हैं.
वर्कशॉप एनर्जी मैनेजमेंट के हिसाब से तो अच्छी रही और इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट में पूरे ने अटेंड की जयपुर की कॉलेज है और इलेक्ट्रिकल यूटिलाइजेशन ऑफ इलेक्ट्रिकल पावर हाउ कैन बी सेव द इलेक्ट्रिकल पावर दिस इज अ मस्ट बी कंटेंट वीडियो और ऑडियो प्रॉब्लम है. थैंक यू एंड थैंक यू.
I think your bandwidth is less. So next program onwards, please try to increase your bandwidth.
एक बार दूसरे सेंटर पे जाके फिर वापस आना यहाँ पे.
फिर वापस आएंगे.
So next, let us go to Vivekanand Institute of Engineering and Technology, Ghaziabad. Vivekanand Institute. Yes, Vivekanand Institute of Engineering and Technology, Ghaziabad. Are you there?
ये आदमी सोता रहता.
Vivekanand Institute of Engineering and Technology, please switch on your mic. आपका mic on कर लेना. Switch on your mic. Yes, we can.
Yes, ma'am. Can you hear me?
Yes, we can hear. Just you can give your feedback.
Ma'am, it was an informative development program, especially for those who are doing their engineering and electrical engineers are really benefited with this. It was an informative program.
Okay.
In addition, I think the subject matter should have been dealt more in depth. For example, in energy management and conservation, the use of, and the impact of the use of CFLs and LED lamps was not covered. And because a lot of problems arise because of the power factor becoming, lagging more. So it leads to more loss of energy than having gained anything from the energy. So I feel similarly, subject matter, especially since it was for the faculty, more in-depth coverage of all the topics would have been in order. Thank you.
As it was only 4 days program, usually we'll have a 5 days program, and I think usually Sir's lectures, CFL and LED,
He was
gives
fully
live.
there, yes.
I've seen, but I don't know what was the reason, and he would have covered. He wouldn't have gone in depth. Anyway, if it is a 5 days program, we used to cover it, and next time we'll surely rectify this. Okay, thank you, sir. Thank you for your feedback. And now let us again go to Jaipur Engineering College. Are you connected? Jaipur, yes, Jaipur Engineering College. Can you hear us? Jaipur Engineering College. Can we have feedback from you? We hear you.
जितेंद्र सर
उसको बोलता है, बताने के लिए उसको बोलता है।
You just decide among yourself and please anyone. We are short of time.
Hello.
Hear you.
कुछ बोल, कोशिश कर रहे हैं बोलने की।
Anyone can please give a feedback. Jaipur Engineering College.
कोऑर्डिनेटर का नाम जो है उनको बोलो ना।
उनके कोऑर्डिनेटर कौन है?
उनके कोऑर्डिनेटर
हेलो हेलो
Hello, you can give a feedback. Can you speak to the coordinator?
ये प्रोग्राम हुआ, ये कैसा हुआ?
आवाज समझ में नहीं आ रही। कोऑर्डिनेटर अजय शर्मा।
एक मिनट साहब को एक बार हैंडल करने देना। क्या रहा प्रोग्राम, हमें ये बताओ कि कैसा लगा आपको?
अजय शर्मा, अजय शर्मा जी, आप कैसे मौजूद यहाँ पर? अजय शर्मा जी, कॉलेज के जो कोऑर्डिनेटर है वो मुझसे अजय शर्मा है। अजय शर्मा जी, आप काइंडली ये बताइए कि प्रोग्राम आपको कैसा लगा और काइंडली प्रोवाइड योर फीडबैक। अजय शर्मा जी।
हेलो हाँ सर, जयपुर इंजीनियरिंग कॉलेज।
यस यस, बताइए
सर। प्रोग्राम बहुत ठीक था। इलेक्ट्रिकल एनर्जी एफिशिएंट के इलेक्ट्रिसिटी, हाउ कैन बी रिड्यूस फॉर द यूटिलाइजेशन इलेक्ट्रिकल पावर, द इक्विपमेंट एंड डिवाइसेस टू रिड्यूस द इलेक्ट्रिसिटी सेविंग एंड energy conservation.
Yes. Energy audit.
Yes sir.
Energy audit भी बताया हमने, बताइए।
Sir, not listening. Hello.
नेक्स्ट कर लो।
Okay, thank you very much. Thank you.
शायद आवाज का कुछ दिक्कत है। ओके।
Now we have taken feedback from all the nodal centers and we want feedback from our students here and participants from here. Here from Nita Chandigarh, any of you want to tell feedback?
Yes.
Give your feedback.
बताइए।
यहाँ यहाँ पे आओ, वो आपकी आवाज सुनेगी नहीं बाकी लोगों को ना। Everyone should listen at distance places, no?
Good afternoon, Dr. Sir. Good afternoon, Chaudhary sir, and good afternoon all the participants. My name is Praveen Shukla. I am a student here in electrical department. जैसा कि आपने देखा कि 4 days का हमारा प्रोग्राम था, उसमें हम लोगों ने एनर्जी ऑडिट और एनर्जी कंजर्वेशन के बारे में काफ़ी कुछ देखा। उसमें अब मेन हमारा टारगेट ये कि प्रोग्राम हो गया, उसके बाद हमने अब क्या सीखा। जैसा हमने देखा कि ईसीओज हमने डिफरेंट इंडस्ट्रीज में ईसीओज हमारे पास हैं कि लूप होल्स क्या क्या सिस्टम है, तो उनको रिमूव करना। उसके बाद कि उससे क्या होगा कि हमारी एनर्जी एफिशिएंसी ऑटोमेटिकली इंक्रीज हो जाएगी। तो ये हम अपने नियर बाई हाउसेज में, खुद अपने घर में, जैसा कि अपने घर से स्टार्ट करेंगे तो जाहिर सी बात हम अपने आसपास के एरिया को की एनर्जी एफिशिएंसी को इम्प्रूव कर सकते हैं। तो अगर खुद से स्टार्ट करें तो जाहिर सी बात ये हो जाएगा, पॉसिबल है करना। थैंक यू।
आप लोगों ने ये सब्जेक्ट, रुको एक मिनट, आप लोगों ने ये सब्जेक्ट पढ़ा हुआ था क्या? एनर्जी एफिशिएंसी नाम की कोई चीज पढ़ी हुई थी आप लोगों ने पहले बीटेक लेवल पे?
सर यस सर।
ओके। एनर्जी ऑडिटिंग?
एनर्जी ऑडिटिंग नहीं पढ़ी।
एनर्जी ऑडिटिंग, अब एनर्जी ऑडिटिंग के पूरे फंडामेंटल्स आप लोगों को क्लियर हैं?
यस सर।
अगर मान लो इंस्टीट्यूट की ऑडिटिंग करनी हो आपको, एनर्जी ऑडिटिंग, आर यू एबल टू डू?
यस सर, डेफिनेटली।
कौन कौन लोग ऐसे हैं अपने स्टूडेंट्स में से जो, प्लीज रेज योर हैंड्स, कि जो एनर्जी ऑडिटिंग कर सकते हैं साइंटिफिकली एवरीथिंग, है ना? जो आपका टाइप ऑफ लोड्स को क्लासिफाई कर सके, उसको रोड के आपके अल्टरनेटिव उसके लिए सजेस्ट कर सके, हैं कहीं पे इलेक्ट्रिकल मोटर्स लगी हुई है, कहीं पे रजिस्ट्री लोड लगे हुए हैं, किस तरह से आप लोग जो है उस क्लासिफिकेशन के साथ पूरी इंस्टीट्यूट की, ऐसे नहीं कि लाइट कम टाइम जलानी चाहिए या CFL लगानी, वो नहीं। मैं ये चाहता हूँ कि पूरी इंस्टीट्यूट का, अगर मैं कह रहा हूँ कि मेरे को एनर्जी ऑडिटिंग करके दो आप, एंड द एरियाज वेयर we people are means where we are consuming more power because we are not scientifically handling that situation. So all of you who are raising the hands, are you capable for doing that auditing? कर सकते हैं? सटी साहब एक इनको प्रोजेक्ट दो।
बिल्कुल।
कितने दिन में कंप्लीट कर सकते हैं ये?
अब ऐसे भी प्रोजेक्ट्स देते ना,
सिर्फ केस स्टडी देना नहीं, मेरे को इम्प्लीमेंट करना है।
नहीं, मैं एक्चुअल
सिर्फ पेपर्स में नहीं चाहिए मेरे को,
रियल टाइम नहीं चाहिए,
रियल टाइम
कराएंगे,
मेरे
पूरा डेटा लेके
आज ये महीने का अगर 4 लाख का बिल आता है बिजली का, आप लोगों की वो साइंटिफिक जो अप्रोच है उससे अगर आप मेरे को 3.5 लाख रुपए का बिल कर देते हैं, दैट नॉट इन पेपर्स, आई वांट एक्चुअली द पेमेंट व्हिच आई एम मेकिंग टू बिजली बोर्ड, इफ दैट यू कैन रिड्यूस that output I want, and can you do that one? मैडम कब तक इनसे आप करवा सकते हैं?
2 महीना नहीं, इम्प्लीमेंट करने में 2 मंथ लगेगा। रिपोर्ट एक महीने में तैयार हो जाएगा। इम्प्लीमेंट करने में 2 महीने लगेगा।
2 महीने। और आपको ये भी पता करना पड़ेगा कौन से ऐसे एरियाज हैं जहाँ पे ज्यादा कंज्यूम हो रही है, सब मीटर्स भी शायद आपको काम में लेने पड़े।
वही ECOs है, एनर्जी कंजर्वेशन अपॉर्चुनिटीज, वो देखने के बाद।
अच्छा, इस बेसिस पे अगर कोई ऑनलाइन कोर्स अब आप लोगों को अटेंड करना हो एनर्जी ऑडिटर बनने के लिए, एनर्जी ऑडिटर बनने के लिए इनको क्या करना है?
एक्चुअली उनको मैंने बताया, एनर्जी ऑडिटर तभी बन सकते हैं जब ये ऑनलाइन एग्जामिनेशन पास कर लेंगे, उसका एक लाइसेंस होता है।
कौन कराता है वो एग्जाम?
वो ऑनलाइन होता है, एक साइट है, वो मैं बता दूंगा इनको।
ब्यूरो ऑफ इंडियन स्टैंडर्ड्स। ओके,
तो लेकिन उसका
ब्यूरो ऑफ इलेक्ट्रिकल एनर्जी,
वो, लेकिन
ब्यूरो ऑफ इंडियन स्टैंडर्ड्स,
उसकी एक पर्टिकुलर साइट है, उसमें जाके आपको ऑनलाइन एग्जाम लिखना पड़ेगा। तो वो आप लिख के लाइसेंस, हमने आपको बताया ना, you have to acquire the license and then you become auditor officially.
ये मैडम इनका एग्जाम कब करा सकते हो, ऑनलाइन वाला एग्जाम?
देखेंगे जो भी है वो सब दे सकते हैं।
हमारी जो NBA की टीम आए उससे पहले हमारे स्टूडेंट्स इनके पास एडिशनल जो एक क्वालिफिकेशन हो, नॉट ओनली दिस एमटेक डिग्री इट इज नॉट सफिशिएंट, इनके हाथ में ऐसी स्किल्स, अगर ये एमटेक के बेसिस पे जॉब भी नहीं लगे, आज जाके ये एनर्जी ऑडिटिंग करने लग जाए, पर्टिकुलर इंडस्ट्रीज में जितनी डिमांड है ऑडिटर्स की,
हो सकता
है ना, दैट इज इनॉर्मस डिमांड। बट ऑल आर बीटेक,
नहीं, सभी कर सकते हैं, not only electrical, electronics engineer can do, instrument, any engineer can do,
mechanical engineer also can do,
mechanical engineer can very well do it, automobile engineer can do it, civil engineer can do it. मैंने इनको बताया everybody can do it, and a minimum qualification required is diploma. So they are all
It
capable
is
of.
Bureau of Energy Efficiency, I
Yes,
think, no?
yes.
Bureau of Energy Efficiency, उनके साथ आपको you have to register for that one,
Yes.
and you have to appear in that examination. Yes.
वो पास करना होगा, ऑनलाइन ही होता है वो
तो
एग्जाम.
इन लोगों के लिए दो प्रोजेक्ट्स हो गए, वन ऑडिटिंग ऑफ दिस होल इंस्टीट्यूट एंड सेकंड वन obtaining that certificate of auditor, official auditor, for becoming official auditor. वो आप लोगों को काम करना है.
ठीक.
Anyone else who will be giving feedback? Yes.
इधर आइए प्लीज.
पहले भी आप लोगों ने कभी इस तरह का प्रोग्राम अटेंड किया था क्या? It is first time. They attended for 5 days.
Yes, yes, yes.
They attended for 5 days.
Yes, yes.
तो एक इनको स्टूडेंट्स का सर्टिफिकेट भी चटर्जी साहब इन लोगों ने अटेंड किया है ये प्रोग्राम है ना, चाहे अपने इंस्टीट्यूट के लेटर एड पे दें, वो इनको अटेंड करने का सर्टिफिकेट जिससे इनको कल को प्लेसमेंट में और इन बच्चों के काम में आए, दैट सर्टिफिकेट दे लेट टू हैव. ठीक है, प्लीज.
Respected Director Sir and Professor Chatterjee Sir and all other faculty and all other my dear friends. I am feeling it is my privilege to attend for this such a useful course for me. So I feel this in this session, power quality issues Professor Jagdish Kumar Sir has spoken. I feel that was only one lecture, that is only limited. Sir is also having some other slides also, because of the shortage of time he is not able to. If Sirs have 2 sessions, it will be good for us to learn more. Okay. So that is one thing what I identified. And same manner on the solar energy, how we have to maximize the trap the solar maximum power. Simi madam explained very well. Thank you madam, thank you very much. Chatterjee sir today he has given very wonderful ideas for us. When we go back to our institute with our students, we can do the projects. Previously also I attended one course on the non-conventional energy sources in Chennai NITTR. It is in around 2003. So based on that ideas, based on that inspiration, with my students, I did a project on solar power. So till today in Government Polytechnic Mahbub Nagar, in electrical staff room, 2 lamps and 1 ceiling fan, it is working with that energy. If power has gone, electrical staff room will be always there, power. So therefore all the staff used to come and sit there when there is shortage of power. So due to that inspiration, all mechanical and some other batches also they have done some projects. So today also Sir Chatterjee Sir has given idea on the street light project, and in automobiles how we have to save the energy, how we have to use that heat energy as electrical energy. With these ideas, when I came back to my institute, with the help of my students, I will try to do my level best. Thank you sir, thank you for your wonderful lectures. You have given a very inspiration, not only for subject, for our life also you have given very good things. Thank you sir, thank you very much for wonderful lecture.
Very good.
Thank you very much for one hour.
हाँ.
A very good afternoon, everyone. Our director, our HOD, and our ma'am, and all the students and the participants. Actually, the thing is, as director sir said, that the main emphasis of our government is on rural development and electrical energy. Plus, Dr. Chatterjee focused upon small hydro projects. Since I am from Himachal, so what got into my mind was to create a device that would be compact, it would be small, it would be efficient, and it won't require the building of any dam or something. So I'm thinking of pursuing my master's project in this field. I have made a basic design, and I have earlier I was not very confident about it, that I should go for it or not, because it came to my mind a few months back. Okay. But now I think I should pursue in that field, because that is the need of the hour, and we should devise something that should be like compact, hybridized, and like synchronized in such a way that we are able to produce electricity for our homes by just using the river water, flowing water. Okay. So I'm working on that thing, and I'll when the paperwork is done, then I'll pursue further it. So I would really like to thank you, sir, that for building up my confidence again in this field. So I'll continue in my thesis work, that project.
Very good.
Thank
On
you, sir.
micro hydro power plants,
Sir, it is basically micro से भी नीचे, it's like nano hydro हो जाएगा.
Pico hydro हो गया.
हो गया है. Okay.
ठीक है. Thank you.
Wonderful. Very
Thank
good.
you, sir.
Okay. Very good.
Anybody else? Gagan, please come.
Very good afternoon to Director Sir, HOD Sir, and my faculty members and students. First of all, from this course, what I have learned is this course is not limited only to that energy conservation, energy auditing. It is also a it plays significant role in improving our environmental conditions as well. It creates lot of awareness among our youth, our students, that yes, it is a need of ours. It's not only that industries or institutes we are going to auditing, we also have to emphasize on our environmental conditions for a future generation. So, and yes, I was just discussing with my sir that a few days back my father was discussing with me that our electricity bill is quite high, means it's about 2 to 3 times more than previous. And when I heard that energy auditing, that seminar, that lecture, I discussed with sir, and sir told us go and have a look over it.
Yes.
Now sir, thank you so much, and definitely I'm going to I'll go home and will check that bills and what is the actually
Lot of things can be done.
yeah, it's not only we are studying, we are having our theoretical works. When we'll go and do our practical things, then only will be. I will say on my behalf that yes, I am electrical engineer.
Very nice.
And definitely I will do this. Thank you so much.
Whatever expenditures you are making here, no, for your food and all, if you can save, if you can help your
Yes,
father.
sir.
Wonderful. That energy bill, if you can reduce,
Sir,
I'll be very happy.
Sir, actually, he is also very happy that stipend I am now having these days. I'm in. मैं अपने expenditures अब थोड़े से handle करना सीख गई हूँ.
वो तो एक्सपेंडिचर थोड़े से नहीं, वो तो 8,000 रुपए है, अच्छा खासा अमाउंट है,
सर वैसे
स्मॉल
वो
अमाउंट.
उनके लिए वैसे इतना मैटर नहीं कर रहा, बट स्टिल बहुत
But
अच्छा
yes.
वो प्राउड वाली फीलिंग है.
Yes.
But thank you so much, sir. You really motivate us, and also Shimi ma'am, Lini ma'am, for and that our previous year I learned a lot from this institute, because from the college I have passed my degree. It was good, but now I came to know what actually standard of engineering.
Yes.
And thank you so much for
Yes.
giving me such a big platform.
And
Thank
you people are very lucky, the type of teachers which you are having here, particularly in electrical engineering department. There is no comparison at all. Even you would have done your MTech from IITs also. I mean, opportunity was there, you could have entered there. But I can compare the level of zeal, enthusiasm these people are having. It's beyond comparison. So you people are very lucky, and whatever time, whatever opportunity you have got, you should encase this one. एक मिनट भी आप लोगों का खराब नहीं होना चाहिए, और कुछ अलग से ही जब आप यहाँ से निकल के जाओ, कुछ अलग से ही दिखने चाहिए. That exactly we want. That's our dream.
And sir, one more thing, they have given us very homely environment, and I'm very thankful to all our teachers. They are just
Teacher, which I'm saying, na, best teacher means every dimension of that teacher is something different. It's not an ordinary dimensions.
thank you so much, sir.
Chalo,
Thank
good.
you. Good.
So every time when we hear from our director, it is just a motivation for us. And let us hear feedback from our director.
Okay, first of all, I'll extend my sincere thanks and best wishes to all electrical engineering department team, the ETV studio team. Even you have observed the team members who are working here, the sincerity which they are having. Everything has to be copied since morning to evening, and those are MTech students. MTech students, seriously, they are doing, and many times I've observed even they are sitting on the floor, they are making some connections, some problems. They are even all the time they are discussing on mobile everything, and they are not getting anything as far as these mobile bills are concerned.
Absolutely.
It is from their pocket only. That exactly we need. That type of dedication we need. The learning from these type of program, it is not only these technical contents we have learned. Everything, even work culture, the dedication of the people, their sincerity, everything through these type of programs has to be learned. Tomorrow we are having 68th Independence Day of the country. Again, I'll be extending my best wishes on behalf of NITR Chandigarh to all the participants who are attending us. These type of programs we have started in the month of September 2012. Earlier, our capacity to impart training in a year was around 4,000 teachers, 4,500 teachers in a year. That was our capacity. Just like this mode of training, no teachers used to come here, we people were delivering. In contact mode we were doing. But in our region, if you see our region where teachers are willing in fact to take training from us, it is starting from Jammu and Kashmir to UP. In our region we are having 9 states. In 9 states, we are having around 5,000 institutes, polytechnic, engineering colleges, if you add together MBA, MCA, every institute if you are adding, it is 5,000. And our capacity was to impart training to 5,000 teachers in a year. So it means on an average, one institute, one teacher. So when I joined this institute 2 years back, I discussed with all faculty members here that how many teachers we are able to touch in fact in a year. They said, sir, 5,000 institutes are there, 5,000 teachers we are able to train. So one institute, one teacher, I said, whole life will go. We won't be able to reach the remotest corner of the country. Our target is the weakest teacher which we are having in the rural area who needs our help. There is no need to impart training to NIT teachers or IT teachers. They are confident, they are having a lot of facilities also. Their infrastructure, the ambience, the other facilities which they are getting, it is enormous. But teacher who is sitting in the rural area and in the remotest corner of the country, there we want to reach. From that particular point of time, we have started this mode of training. In fact, initially we have started with video conferencing. But in video conferencing, at end point where teachers are sitting, minimum connectivity has to be 1 Mbps. So every institute, particularly in rural areas, that connectivity is not available. And in that case, we were having 5 these video conferencing equipments here. Our persons used to come to, one is going to Lucknow, another one is going to Jammu, another one going to Delhi, like that one. Personally, they used to go, they were installing those video conferencing equipments there in 5 days program. Again, they used to go back there for bringing that video conferencing equipment, setting up another institute, because these programs are the regular feature of this institute. Then these people who are sitting here, these students who are sitting here, I requested them that you please innovate some other mechanism. This is a very costly affair, time consuming, lot of efforts are needed. So if any other mechanism you can innovate, I think just like one of the boy was saying that this micro or and even lower than that one, I'll try to devise one mechanism where idle power generation can be. In the same fashion, they have tried. Now the type of mechanism of transmission which we are having, it is through Google Hangout. This institute is the institute which has utilized the social media up to the maximum possible extent, Now through this Google Hangout, only if someone is having this dongle, one laptop and one LCD projector. So whatever we are delivering here, through that dongle, through IP based the connectivity we are having, and it is being received on in the laptop. That laptop is connected with the LCD projector, and ours the delivery is getting received at that particular point of time. And when they are speaking from that side, you know what they are using? They are using this laptop mic only, and the pictures which we are receiving from the laptop camera only. So the infrastructure which they are having, it is only laptop. No smart classroom, no video conferencing equipment, no cameras, nothing is there. Just laptop they are having. So this innovation which these people have done, it is wonderful. In that year, during 2012-13, in that year, in addition to those 5,000 teachers, around 5,500 more teachers we could train. So our strength has become that time more than 10,000 teachers in a year. Last year we have trained 15,000 teachers. This year our target is for 20,000 teachers. And this 12th 5-year plan, when it will be ending in 2016, our target is every year we should be able to impart training to 1 lakh teachers. Country is having lot of hopes from these institutes. You may not be knowing, this institute has been established in 1966. 1966 means that time we were fighting with Pakistan, we were fighting with China. Just we became independent, not longer time was there. And that time production of wheat in our country was only 6 million tons. We were waiting from, that time most of the wheats which India was using, we were importing that time. Whatever resources we had that time, we were spending on importing these food items. But that particular point of time, our policy makers, our visionary people, they were planning to have these type of institutes who can impart training to technical teachers. You can imagine the situation. One side we were fighting for food. Another side our visionary people were thinking for having this type of institute who can impart training to technical teachers. So from that point of time we have started, in tough time we have started, it means responsibility of ours, responsibility of all the teachers who are having, it is very, very special. And again the day is coming, tomorrow day is coming. Again we'll have to take oath that whatever resources we are having, it has to be utilized up to the maximum possible extent. Your railways are working for 24 hours. Your hospitals are working for 24 hours. Your electricity board is working for 24 hours. Why not these academic institutes? It is not meant only for utilizing 5 hours, 6 hours. Our duties are for 24 hours. Our Prime Minister is saying that 18 hours working. Everyone should work 18 hours if we want to compete at global level. We were competing. We were competing. You may not be knowing, in the 17th century, when East India Company came, India was the richest country in this whole world. Whole world we were the richest. And now we are at 11th number. Our contribution in GDP that time was 27% of the total GDP which world was having. In 1947 when they left, that time it was 1.5%. From 27% to 1.5% we came. First university which world had, we were having. Taxila. It was around 2300 years back. In that university, 65 specialized courses were there. Then Nalanda came. In Nalanda around 1300 years, 1400 years back, in that university 10,000 students were studying. Library building of that university was of 9-storied. Not a single institute now in India which is there, which is having 9-storied library building. In that university, Nalanda University, there were 3,000 professors that time. From 40 countries, students were studying here in India. First letter which has been written on this earth, that was by Indians. Around 5,000 years back, Ved jo likhe gaye the, first Indians have started writing on this earth. सबसे पहले जो भी किसी काम की शुरुआत हुई थी, that was done by Indians. We were leading, in fact, in every aspect we were leading. Financially, I am saying 27% of GDP we were having. In education, we were dominating. In manufacturing, we were dominating. Now situation has changed. Even all the universities, MIT, Harvard, their lifespan is only 200 years. And we have started around 2000 years back. The surgery which we are doing, Chitti surgery, even latest plastic surgery which we are doing, 2600 years back our doctors were doing in India. Those type of capabilities we had. Today the highest wealth which we are having in our country, highest wealth I am saying, that is you people. That is our strength. You people are not only human beings, you are human resource for this country. And just doing electrical engineering, it is not sufficient at all. What you are contributing for the betterment of the society, how you will be contributing, that's very, very important. सिर्फ आपका यहाँ इंजीनियरिंग करके जाना, इलेक्ट्रिकल मशीन्स पढ़ लेना, लॉसेस पढ़ लेना, पावर फैक्टर पढ़ लेना, it won't serve. End of education is your character. मानव मूल्य जो है, that's very, very important. For that purpose we were recognized, and even India is being recognized for that purpose. Just one example I was going through, even about our education system today. Some of the students who have been denied by IIT for admission, BTech admission in computer engineering, they have got scholarship in Harvard, they have got scholarship in MIT. That much difficult education in India we are having. जिस बच्चे को IIT में एडमिशन का मौका नहीं मिल रहा है, उसको हार्वर्ड यूनिवर्सिटी में स्कॉलरशिप के साथ पढ़ाई का मौका मिल रहा है. It means our competition in our country is tough as compared to them. In US, 34% NASA engineers, scientists are from our country. We have that dream, in fact, continuously. The resources, the students who are going out from here, you should be something very, very special, not an ordinary student. You are not studying in an ordinary institute. Every dimension of US, and we should feel proud that yes, you people are the students of NITER, and same type of program, same type of input we would like to give to every teacher of this country. Society is having lot of hopes from us, from the teachers particularly. 60% of our GDP is coming through service sector only. Service sector means human being, we people. So you can imagine how big role we people are playing. And in that big role, we people are the molders. In fact, we are molding you. Our role is greater than the role of God. God has just created. We people are molding. Teachers are responsible for that one. In our career, one teacher is molding around 3,000 students. और एक बच्चे को भी अगर सही रास्ता हमने दिखा दिया, that itself will be a wonderful contribution. So in your life, just become a good human being, जिसकी आंखों में आंसू आते हों. Don't become just like a robot. I've never seen any robot who is weeping. Robots can do anything, any miracle he can do. Even this electrical auditing, this theater operation, construction, everything robot can do. But I've never seen any robot which is weeping. We people should. If someone in difficulty, we should weep. Even financially, we are not dominating. USA is dominating. Even in our country today, if I'm saying someone is having 1 rupee today, वो भी भूखा नहीं मरता यहाँ पे. If you are in Karnataka, many mutts are there. If you are in northern part of the country, many gurdwaras are there, जहाँ पे लंगर चलते हैं. आपके सड़कों पे प्याऊ है. आप पूरे यूएस में घूम लेना, कहीं पे जो है न आपको खाना खिलाने वाला है, न आपको पानी पिलाने वाला है. That's our संस्कृति. So when you'll be going out from here, you should be the richest person as far as our traits are concerned, as far as our traditions are concerned, for which we people work. So my message is on this particular eve, first of all, the congratulations for successful completion of this program. Whatever you have learned, it should be implemented. And third thing, you should become the best human being on this earth. That's my best wishes. Again, thanks for my whole team who are working day and night and for this great success. Thank you very much. Best wishes.
Thank you, sir. Thank you for your inspiring words. So we have come to the end of the session, and I would like to give a small quote. We simply must balance our demand for energy with our rapidly shrinking resources. By acting now, we can control our future instead of letting the future control us. I, Shimi, deem it a great honor and privilege to stand before you to deliver the oath of thanks on the occasion of the valediction of the STC on efficient energy management techniques through ICT. First and foremost, I would like to express my gratitude to the liaison officer of UP State and the coordinators of various nodal centers who have arranged for the connectivity of this program. I would like to thank all the experts of this course for spending their valuable time and sharing their knowledge with us. I am highly thankful to Dr. MP Punia, who is the backbone of this whole concept of ICT-based program. Thanks are also due to the whole team of ETV department, Mr. Vinay Vadera, Mr. Kapila, Mr. GP Pandey, Mr. JL Verma, Mr. Ashish, Mrs. Savita Banot, Mr. Harjot, Mrs. Deepika, Mr. Paramjeet, under the leadership of Dr. S.S. Patnaik, without whose involvement this program could not have been materialized. Let me sincerely thank the faculty in charge Internet Administration and his team for arranging the Internet connectivity. Thank you, Dr. Ramakrishna and team. The successful culmination of this program owes much to our coordinator of this program, Dr. S. Chatterjee. Thank you, sir. In the end, let me thank all the participants without whose participation this program wouldn't have been materialized. Lastly, let me not forget the names of the different departments and individuals who have extended their best cooperation in the conduct of this program. The Institute Estate Department, Electrical Maintenance, Air Conditioning, Media Center, Canteen and Mess. Overwhelming thanks are due to these departments and every individual involved. Let me also extend my heartfelt thanks to all the faculties, staff members, PhD scholars, ME students of the Electrical Engineering Department who have taken real interest in the planning of this program. Thank you once again. Thank you.
Very good.
Thank you, sir. Thank you very much. Gracias.